Hey guys, good morning and welcome back again to your Unacademy NEET English channel. So my dear students, this particular session is going to be one of the most important sessions when it comes to the organic chemistry. Because in this particular session, which I'm going to keep very short and precise, right? I mean for 2.5 hours, I'll try to complete the whole IUPAC nomenclature in one shot. So wherever you see IUPAC nomenclature from now onwards, you should be in a position to name all the compounds in the organic chemistry as per IUPAC. That is my promise for sure after watching this particular video. First of all, we'll be starting with the nomenclature of alkanes. Then we are going to discuss the nomenclature of alkenes. Right? Then we shall be discussing the nomenclature of alkynes. Then we shall be discussing the nomenclature of cyclic compounds, Spiro compounds, Bicyclo compounds, and compounds containing the functional groups. Compounds containing the functional groups. So this is going to be our today's session flow, my dear students. We shall be starting with the alkanes, then alkenes, alkynes, cyclic compounds, Spiro compounds, Bicyclo compounds, and the compounds containing the functional groups, right? So let's get going then. Let's get started with the nomenclature of alkanes. With the nomenclature of alkanes. I am not going to give you a lot of rules. Let me tell you that honestly. Right now, I'm sure you would have studied a lot of rules in IUPAC nomenclature. I'll just give you like 3 to 4 rules which you have to remember, and I'm 100% sure you can name all the compounds in your organic chemistry for sure, right? So starting from the exact basics. My dear students, the first rule which you have to remember from now onwards. Whenever you try to name any organic compound, as per new IUPAC, whenever you try to name any organic compound, the first and the most important rule is you have to select the longest possible carbon chain. This is the first rule which you guys are going to remember. Select the longest possible carbon chain. This has to be always your first step, right? This has to be always your first step. Whenever you try to name any organic compound, you have to select the longest possible carbon chain, okay? For example, how do we select the longest possible carbon chain? My dear students, try to understand. First of all, I'm sure you would have studied this particular notation. If not, let me tell you, this is your CH3, this is CH2, this is CH2, this is CH2, CH2, this is CH3, right? Sorry, this is CH, this is CH2, and this is CH3. I'm sure this kind of notation every one of you would be already knowing, right? Perfect. So these terminal carbons are your CH3, right? Okay, this is CH2, CH2, CH2. This will be CH, right? This will be CH2, this will be CH3. Now, my dear students, the first rule says that you have to select the longest possible carbon chain. Now, if I ask you, what do you think? Which one is going to be the longest possible carbon chain here? It's very simple. Have a look. This is 1, 2, 3, 4, 5, 6, 7. Can I say this is going to be the longest possible carbon chain here? Right? This is going to be the longest possible carbon chain here. So you are going to select this particular chain as per rule number 1. Look at this particular compound. If I ask you, select the longest possible carbon chain here. Select the longest possible carbon chain here. My dear students, as far as I see the compound, the longest possible carbon chain will contain 1, 2, 3, 4, 5, 6, 7, 8, and 9, right? So this is going to be your longest possible carbon chain in this particular compound. As simple as that, right? Look at this particular compound. In this particular compound, what do you think is going to be our longest possible carbon chain? Have a look. If I start from here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? 10 carbon atoms in this particular chain if I select this one. But if you select the other one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So if I select this particular carbon chain, this carbon chain contains the maximum number of carbon atoms. So this is going to be my longest possible carbon chain over here in this particular compound. So your first rule, which you are going to remember from now onwards, when you try to name an organic compound, you have to select the longest possible carbon chain in the compound. As simple as that, right? This is your rule number 1. My dear students, My dear students, now there comes a point. The point is, if more carbon chains are multiple in number, then select the chain with maximum number of branches. What does that mean? What does that mean? Well, look what it exactly means. See, over here I've taken a compound. The same compound I've repeated here. Try to understand what exactly I'm going to talk about. My dear students, in this particular compound, if you select this particular carbon chain, in this carbon chain, how many carbon atoms do we have? 1, 2, 3, 4, 5, and 6. In this chain, I've got 6 carbon atoms. As simple as that. Now, people, over here, if I select this as the carbon chain, how many carbon atoms do we have? 1, 2, 3, 4, 5, and 6. Here also we have got 6 carbon atoms. Now, which chain is going to be my parent chain over here? Which chain do I need to select over here? My dear students, over here, I have selected 2 carbon chains, and both the carbon chains are containing 6 carbon atoms. Now, you will be selecting that chain as the main chain. You'll be selecting that chain as the parent chain, which will contain more branches. Right? Over here in this particular chain, how many branches are there? There is only 1 branch, right? If you select this as the chain, there are 1 and this is 2. There are 2 branches, right? So which chain you are going to select over here? Which one is going to be your main chain? The chain which I've selected here, that is going to be your parent chain, which you guys are going to select. As simple as that, right? Perfect. Now, look at this particular compound. What I can do over here is, I can select this as the main chain. If you select this as the main chain, how many carbon atoms are there in the main chain? It's 1, 2, 3, 4, 5, 6, 7, 8, right? 8 carbon atoms. Now, my dear students, if I select this as the main chain, try to understand. 1, 2, 3, 4, 5, 6, 7, and 8. If I select this as the main chain over here, again, how many carbon atoms do we have? You have got 8 carbon atoms in the main chain. Perfect. Now, which one am I going to prioritize? Should I be calling this particular chain as the parent chain over here, or the first one? Which chain am I going to select? My dear students, over here, the chain which I have selected, it contains 8 carbon atoms. The chain which I have selected here, again, it contains 8 carbon atoms. Now, which chain do I need to prioritize? Which is going to be my parent chain? That chain is going to be my parent chain, which contains maximum number of branches. Over here, how many branches do we have? This is the first branch. This is the second branch. Only 2 branches. Look at this one. This will be my first branch. This is my second branch. Here you have got the third branch. Here you have got 4 branches. So this particular chain has got 4 branches. So this second chain is going to be my parent chain, which I'm going to consider over here. Right? As simple as that. So, my dear students, remember this particular statement. If more carbon chains are multiple in number, then select that chain which contains maximum number of branches. As simple as that. I hope you got to know exactly how to select the longest possible carbon chain, right? My dear students, once you are done selecting the longest possible carbon chain, the second rule says that you have to start numbering. You have to give numbering to the carbon atoms in the main chain. And how you are going to do the numbering? Try to understand. The rule says first locant should get the minimum number. My dear students, look at this particular compound. First of all, I'm going to select the longest possible carbon chain. Let's assume this is my longest possible carbon chain over here, right? This is my longest possible carbon chain. Now, I've got 2 ways to do the numbering. Either I'll do the numbering from left to right, or I'll do the numbering from right to left. 2 possibilities I have. If I do the numbering from left to right, this is going to be 1, this will be 2, this will be 3, carbon number 4, carbon number 5, right? Now, if I do the numbering from right to left, this is going to be 1, carbon number 1, this will be 2, this will be 3, this will be 4, this will be 5. Perfect. My dear students, if I do the numbering from left to right, the first locant is getting number 4. If I do the numbering from right to left, the first locant over here is getting number 2. The first locant is getting the number 2. The rule says first locant should always get the minimum number, right? First locant should get the minimum number. So where is the first locant getting the minimum number? In the second case. So you will do the numbering from right to left. As simple as that, right? As simple as that. In this particular case, you will be selecting the longest possible carbon chain, and after that you'll start the numbering. Now you have got two ways, either to start the numbering from left to right or to do the numbering from right to left. Now let's try to understand how to do the numbering exactly. If I start the numbering from left to right, this is going to be carbon number 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7, right? So the first locant over here is getting number 5. First locant over here is getting number 5. Okay. If you start the numbering from right to left, if you start the numbering from right to left, this is going to be 1, this will be 2, 3, 4, 5, 6, and 7. If you start the numbering from right to left, then the first locant is getting number 2. And the rule says first locant always should get the minimum number. So you'll be giving the numbering, you'll start the numbering from right towards the left. Done, understood? Look at the next case. Look at the next case. Again, you have got two possibilities. Start from left to right. If you start from left to right, what is going to be? 1, 2, 3, 4, 5, 6, 7. Right? The first locant over here is getting number 4. The first locant is getting number 4. Now do the numbering from right to left. 1, 2, 3, 4, 5, 6, and 7. If you do the numbering from right to left, the first locant is getting number 2. Right to left, the first locant is getting number 2. And the first locant always should get the minimum number. So you will give the numbering from right to left. So my dear students, number one, try to understand. First of all, you have to select the longest possible carbon chain. Right? You have to select the longest possible carbon chain in the compound. Perfect. Now, for example, if you are able to select more than one longest possible carbon chain, if you are able to select more than one longest possible carbon chain, then prioritize that carbon chain which contains more branches. Once you are done selecting the longest possible carbon chain, you will have to do the numbering of the atoms, of the carbon atoms in the chain. Right? How to do the numbering? First thing, first locant always should get the minimum number. This has to be in your mind all the time. First locant always has to get the minimum number. Perfect. You'll be prioritizing that. Now, my dear students, try to understand a few more things. As I told you, first locant always has to get the minimum number. Right? Now comes one more point. If first locant is same, then go for the lowest sum rule. For example, you are unable to decide with the help of first locant. If you are unable to decide with the help of first locant, then you are going to follow the lowest sum rule. What this lowest sum rule is all about? Let's have a look. Let's have a look, people. First of all, let me start the numbering from left to right. This is 1, 2, 3, 4, 5, 6, and 7. Right? The first locant, the first substituent is getting the number 2. The second substituent is at number 3. Right? The third substituent is at number 6. Perfect. Now, if I start the numbering from right to left, this will be 1, this will be 2, this will be 3, 4, 5, 6, and 7. Perfect. The first substituent is getting number 2. The second substituent is getting number 5. And the third substituent is getting number 6. Perfect. The third substituent is getting number 6. So I've written the locants over here. Now try to understand. The first locant here is getting number 2. Here also the first locant is getting number 2. So you are unable to decide with the help of the first locant rule. Now, which rule you are going to use? The lowest sum rule. Take the sum of these things. 6, 3, 9 plus 2, 11. So the sum of these locants is 11. Here the sum is 6, 5, 11 to 13. The sum is 13, my dear students. So wherever the sum will be the least, that is going to be the actual order of the numbering. The sum is least here. So this is going to be the actual order of numbering. Perfect. So my dear students, whenever you have to start giving numbering to a carbon chain, first go for the first locant rule. The first locant should get the minimum number. If you are unable to decide from that, then go for the lowest sum rule. Right? Sum of the locants has to be minimum. Sum of the locants has to be minimum. Right? Sum of the locants has to be minimum. My dear students, if you are unable to decide on the basis of lowest sum rule as well, if you are unable to decide on the basis of lowest sum rule as well, then what do we have to do? what do we have to do? We have to follow the alphabetical order. We have to follow the alphabetical order. What does that mean? Try to understand. First thing, let me start the numbering from here. 1, 2, 3, 4, 5, 6, and 7. Left to right, I've started the numbering. Perfect. Now again, from right to left. This is 1, this is 2, 3, 4, 5, 6, and 7. Perfect. These are two ways I can do the numbering. Now look at this particular case. The first substituent is at third position. Second substituent is at fifth position. Right? Second substituent is at fifth position. Perfect. Similarly, look here. Look here. The first substituent is at third position. The second substituent is at fifth position. Perfect. Look at the first locants. The over here, the value is 3. The value is 3 here. So you cannot decide on the basis of the first locant. Now, what you are going to do? You are going to use the lowest sum rule. 5 plus 3 is 8. 5 plus 3 is 8. So you are unable to decide on the basis of the lowest sum rule as well. Now, what is left? Now you are going to follow the alphabetical order. What alphabetical order exactly? See guys, this is basically your CH3 here. This is methyl group. This is methyl group. This is CH2CH3. CH2CH3 means C2H5. This is your ethyl group, right? This is your ethyl group. This is, here you have got methyl group. Here methyl group is attached and here ethyl group is attached. Perfect. Now, methyl starts with M. Ethyl starts with E. Alphabetically, in the alphabetical order, which letter comes before M or E? E comes before. So give priority to ethyl. Give priority to ethyl. So ethyl should get the minimum number. Ethyl should get the minimum number. If you are doing the numbering from left to right, then ethyl is getting number 5. If you are giving the numbering from right to left, then ethyl is getting number 3. So this particular numbering is correct over here. Got it? As simple as that. I hope it's clear. I hope it's clear. Right? I hope it's clear. Now guys, this is the basic structure. This is the basic structure, which I'm sure all of you must be knowing. Word root, primary suffix, secondary suffix, prefix, etc., etc. Let me not go into the details of it. Let me exactly show how do we utilize it. How do we utilize it? By the way, do you know this particular thing? For carbon number 1, we use the word root myth. Carbon number 2, eth. Carbon number 3, prop. Carbon number 4, 4 carbon atoms means but, pent, hept, etc., etc. Right? You must be knowing all this, something which you study in your class 10th basically. If there are 10 carbon atoms in the main chain, the word root is going to be dec. 11 carbon atoms in the main chain, word root undec. 12 carbon atoms, dodec, tridec, tetradec, pentadec, hexadec, right? 20 carbon atoms in the main chain, ICOS, word root is going to be ICOS. Let's try to utilize all these things and let's get to know whether we are able to name some basic compounds or not. Have a look, people. Have a look. Have a look, people. Try to understand. Look at this particular compound. What should be its name? It is the simplest. This is carbon number 1. This is 2. This is 3. This is 4. Perfect. Main chain is selected. Numbering is done. Numbering is done based on the rules which we have discussed till now. Now, at carbon number 2, you have got methyl group. So it's going to be 2. It's going to be 2 methyl. Let me tell you, number and letter separated by dash. Hyphen. Number and letter separated by hyphen. Right? So it's going to be 2 methyl. In the main chain, there are 4 carbon atoms. So it's going to be but. Everywhere it's a single bond. So it's going to be ane. This is going to be the name of the compound. Simple. Look at the second one. 1, 2, 3, 4, 5, and 6. 6 carbon atoms in the main chain. At carbon number 2, you have got methyl group. So what should be the name? It's going to be 2 methyl. It's going to be 2 methyl. And it's going to be hexane. H-E-X, hex. Everywhere there is a single bond. So it's going to be ane. As simple as that. These are some basic compounds which I'm giving you. You keep on telling me in the chats continuously. Continuously the chat should rotate. Right? Look at this particular case. Let's start the numbering from here. 1, 2, 3, 4, 5, and 6. Now have a look. At carbon number 2, there is a methyl group. At carbon number 5, there is again a methyl group. So how many methyl groups we have? We have got 2 methyl groups. We have got 2 methyl groups over here. Perfect. We have got 2 methyl groups over here. So what should be the name of this particular compound? At carbon number 2, and At carbon number 5, we have got two methyl groups. Two numbers are separated by comma. Two numbers are separated by comma. So it's going to be 2, 5. Now, how many methyl groups? Two methyl groups. So it's going to be dimethyl. It's going to be dimethyl. Dimethyl. Tell me how many carbon atoms in the main chain? 6 carbon atoms in the main chain. So word root hex. Everywhere is a single bond. If it is a single bond, so ane I'm going to use. So 2, 5 dimethyl hexane is going to be the name of this particular compound. Simple and basic. Right? Darshini, HSP sir is also here. HSP sir is also here. It's been long. I have been teaching physical, right? So I thought of taking some chapters of organic. Similarly, HSP sir, it's been long. He has been taking organic. So he'll be also taking some chapters of physical. Just to change. Just for a change. And it's completely your wish to follow the lectures. Okay? Right? HSP sir is here only. He is here only. I'm not going to leave him at any cost. Okay? He is here only. He is the god of organic. He will remain the god of organic. Okay? It is just, I'm also trying a bit just to make you understand. Right? Okay. Look at this particular case. Look at this particular case. Try to name this particular compound. Have a look, people. Have a look. You have to start the numbering first of all. Start the numbering. Will you start the numbering from left to right or right to left? If I start the numbering from left to right, then the first locant will be getting number 3. If I start the numbering from right to left, then first locant will get number 2. First locant should get the minimum number, right? Let me call this as carbon number 1, this is 2, this is 3, this is 4, this is 5, this is 6. Perfect. So my dear students, try to understand. At carbon number 2, you have got a methyl group. You have got a methyl group. At carbon number 4, this is CH2, CH3. CH2, CH3 means C2H5. So this is ethyl group. This is ethyl. This is methyl group, this is ethyl group. Right? Now, should I write methyl first or should I write ethyl first? Methyl starts with M. Ethyl starts with E. In the alphabetical order, E comes before M. So I'll prioritize ethyl first while writing the name. So it has to be 4-ethyl. It has to be 4-ethyl, 2-methyl. 4-ethyl, 2-methyl. Then in the main chain, 6 carbon atoms. So the word root is hex. Everywhere there's a single bond. So it's going to be ane everywhere. So this is the name of the compound. As simple as that. Right? Yes? Now, my dear students, look at this particular case. Start the numbering. 1, 2, 3, 4, 5, 6, and 7. Perfect. At carbon number 2, methyl. At carbon number 3, methyl. At carbon number 4, ethyl. Perfect. Methyl starts with M. Ethyl starts with E. Prioritize ethyl. Prioritize ethyl. So it's going to be, at carbon number 4, you have got ethyl. So it's going to be 4-ethyl. 4-ethyl. Now it's going to be 2, 3 dimethyl. It's going to be 2, 3. It's going to be dimethyl. Dimethyl. In the parent chain, how many carbon atoms? 7 carbon atoms. So the word root is hept. Word root is hept. Everywhere in the main chain, it's a single bond. So I'll be using ane over here. So this is going to be the name of the compound. Simple. You keep on telling me the names in the chats. I want everyone to write the names in the chats continuously. Right? Do not wait for me. You write your answer. You write your answer. Because these are the basic compounds which I've started with. Slowly, you'll see how I'll scale up the level of the questions. Right? See guys, look at this particular one. Look at this particular one. Start the numbering from here. 1, 2, this is 3, 4, 5, and 6. At carbon number 3, it's ethyl. At carbon number 4, it's again ethyl. So it is going to be basically 3, 4 diethyl. 3, 4 diethyl. In the main chain, 6 carbon atoms. So it's going to be hex. Everywhere single bond. So it's going to be ane. Perfect. As simple as that. As simple as that. Now guys, whatever substituents were attached with the main chain, they were either methyl, ethyl, propyl, butyl, right? Simple substituents were attached till now. Now there can be complex substituents attached to the main chain as well. Let's say this is your main chain over here. This is your main chain over here. Have a look. Carbon number 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7. Right? This is your main chain. This is your main chain. Now, in this particular main chain, towards this main chain, a complex substituent is attached. This is not a simple substituent. This is not a methyl. This is not ethyl. This is not propyl. It's a complex substituent. How do we name a complex substituent? Try to understand. Try to understand how do we name it. First of all, at carbon number 4, we have got a complex substituent. At carbon number 4, we have got a complex substituent. Now, first thing, I'll name this complex substituent. How exactly am I going to name this complex substituent? My dear students, in the complex substituent, again I'll start the numbering. In the complex substituent, again I'll be starting the numbering. Let me call this as carbon number 1. Let me call this as carbon number 2. Right? Now, at this particular carbon, there is a methyl group. There is a methyl group. So I'll write 4 dash bracket. 4 dash bracket. At carbon number 1, what do we have? We have got methyl. At carbon number 1, we have got methyl. This is going to be 2 carbon atoms means it's going to be ethyl. It's going to be ethyl. At carbon number 4, you have got a complex substituent. In the complex substituent at 1, at position 1, methyl ethyl. Methyl ethyl. In the main chain, 7 carbon atoms. So it's going to be hept. Everywhere is a single bond. So it's going to be heptane. So this is going to be the name of the compound. As simple as that. Right? Perfecto. Right, people? Now comes the point. Let's assume in the main chain, towards the main chain, there are 2 same complex substituents attached. Let's say there are 2 same complex substituents attached. 3 same complex substituents attached. 4 same complex substituents attached. Remember, if there are 2 same complex substituents attached, you'll be using the term bis. 3 same complex substituents, you'll be using the term tris. 4 same complex substituents attached, you'll be using the term tetrakis. Right? 5 same complex substituents attached, you'll be using the term pentakis, and so on. And so on. Now, try to understand how exactly am I going to name this particular compound. Calling this, for example, as carbon number 1, this is 2, this is 3, this is 4, this is 5, 6, 7, 8, and 9. In the main chain, 9 carbon atoms. Right? Here you have got a complex substituent. Here you have got a complex substituent. Are the complex substituents identical? Absolutely, the complex substituents are identical. How many identical complex substituents we have? 2. So I'll be using the term bis. I'll be using the term bis. I'll be using the term bis. Right? So my dear students, how you are going to name it? I'll be using the term bis. I've used the term bis. Perfect. Now at carbon number 4, at carbon number 4 and 5, at carbon number 4 and 5, two same complex substituents were there. So it's going to be 4, 5 bis. 4, 5 bis. Right? Now, how do we name a complex substituent? In the complex substituent, again, you have to start the numbering. This is 1, this is 2. This is 1, this is 2. So at carbon number 1, this is methyl and this is going to be ethyl. So at carbon number 1, it's methyl ethyl. Right? This bis tells you you have got 2 same complex substituents. Right? Perfect. At carbon number 1, it's methyl and it's going to be ethyl. In the main chain, there are 9 carbon atoms. So none, everywhere, single bond in the main chain. So ale. Very simple and basic. Very simple and basic. Imagine, my dear students, imagine there was one more complex substituent attached. The same complex substituent, one more attached. Then it will be 4, 5, something. It's going to be tris. Then it's going to be 1 methyl ethyl. Right? Then it's going to be non-ale. Perfect. As simple as that. Right? So 4, bis, and this is going to be the name of the compound. So I hope you can easily solve these sort of basic questions from now onwards. These were just the basics. These were just the basic compounds whose name I'm sure easily from now onwards you can do. Now guys, try to understand. Let's exactly see how do we name alkenes. Right? Slowly we'll be making the level of the questions complex. Right? Let's try to name the alkenes. First of all, 2 things you have to keep into consideration while naming an alkene. Double bonded carbon should receive the lowest number. Double bonded carbon should receive the lowest number. Maximum multiple bonds to be included in the main chain. Double bonded carbon should receive the minimum number. Right? Maximum multiple bonds to be included in the main chain. Now, look at this particular molecule. Look at this particular compound. Have a look, people. Double bond has to get the minimum number. So start from here. This is 1, 2, 3, 4, 5, 6, 7. Right? So in the main chain, what do we have? In the main chain, how many carbon atoms? 7. So it's going to be hept. It's going to be hept. Right? At carbon number 2, there's a double bond. For double bond, what do we use? We use ene. So hept to ene. Simple. Perfect. Now, here you have got how many double bonds? 2 double bonds. Maximum multiple bonds to be included in the main chain. Maximum multiple bonds to be included in the main chain. Right? So start the numbering from here. 1, 2, 3, 4, 5, 6, and 7. So at carbon number 3, you have got methyl. So at carbon number 3, you have got methyl. At carbon number 3, you have got methyl. In the main chain, 7 carbon atoms. So you will be using the term hept. You will be using the term hept. Now, my dear students, remember, if in the main chain, there are more than 1 double bonds. If in the main chain, there are more than 1 double bonds or more than 1 triple bond. In the main chain, if there is more than 1 double bond or more than 1 triple bond, then what do? I won't be using the term hept here. I'll be using the term hepta here. Hepta. If the main chain contains more than 1 double bond or more than 1 triple bond. After the word root, I'll be using the term A. So hepta. Hepta. At carbon number 1 and at carbon number 5. At 1 and 5. You have got 2 pi bonds. Right? 2 pi bonds. So it's going to be diene. This is going to be the name of the compound. Clear? Clear, people? Look at this particular compound. Maximum multiple bonds to be included in the main chain. This is 1, this is 2, this is 3, 4, and 5. Perfect? Right? So the word root has to be pent. Word root has to be pent. Is it going to be pent or penta? It's going to be penta. Right? At carbon number 1 and 3, 1, 3, it's going to be diene. 1, 3, diene. Is every single thing clear till here, people? Quickly in the chats. Is every single thing clear till here? Quickly, let me know in the chats. Okay? Okay, guys? Alright, let's move on to a few more. Start the numbering. Keep on writing the names in the chat. Start from here. This is carbon number 1, this is 2, this is 3, this is 4, this is 5, 6, and 7. So first of all, it's going to be hept or hepta. It's going to be hepta. At carbon number 1, 3, and 5. So it's going to be 1, 3, and 5. It's going to be triene. It is going to be triene. Right? Yes. Look at the next one. Maximum multiple bonds to be included in the main chain. So this is going to be my main chain. This is going to be my parent chain over here. Now start the numbering. Start from here. 1, 2, 3, 4, and 5. Or you can start from here as well. It won't make a difference. 1, 2, 3, and 5. 1, 2, 3, 4, 5. At carbon number 3, you have got a substituent. This is CH2, CH2, CH3. So it's a propyl group basically. So at carbon number 3, you have got a propyl group. In the main chain, 5 carbon atoms. Right? So it's going to be pent. Is it going to be pent or penta? It's going to be penta. At carbon number 1 and 4. It's going to be diene. It is going to be diene. So this is going to be the name of the compound. As simple as that. Look at the next one. Again, I'm telling you. Multiple pi bonds to be included in the main chain. Right? So this is going to be your main chain first of all. Then only multiple pi bonds will be included. Now, will you be starting the numbering from top or from bottom? If I start numbering from bottom, this is 1, this is 2, this is 3. Right? This is ethyl group. Here you have got methyl group. If I start from numbering from the bottom, then at carbon number 3, you have got an ethyl group. At carbon number 4, you have got a methyl group. Right? But if you start the numbering from top to bottom, at carbon number 3, you have got methyl. At carbon number 4, you have got ethyl. Methyl starts with M. Ethyl starts with E. In the alphabetical order, E comes before M. So prioritize E. So Ethyl should get the minimum number. So start from here. 1, 2, this is 3, this is 4, this is 5, this is 6. Right? While writing also, you'll prioritize ethyl first. So it is 3 ethyl. It is 3 ethyl. 3 ethyl, comma 4 methyl. 3 ethyl, 4 methyl. In the main chain, 6 carbon atoms. So it's hex. Is it going to be hex or hexa? It is going to be hexa. Because 2 double bonds in the main chain. Hexa. Right? Hexa. And it's going to be 1, 5. 1, 5. And it's going to be diene. Perfect. As simple as that. I believe it's clear. I believe it's clear. Let me know once in the chats if it's clear. I hope you got to know how do we name exactly the alkenes. I did not mix alkenes, alkynes yet. Just wait for it. Slowly, slowly, things will get complex. Slowly, slowly. Now let's talk about alkynes. Alkynes. So there is a triple bond. There is a triple bond. Perfect. Now, my dear students, same rules, whatever we have discussed till now, we are going to use the same rules. Let's call this carbon number 1, this is 2, this is 3, this is 4. So it's going to be but. At carbon number 1, it's going to be ine. So but 1 ine. Perfect. Now start the numbering. 1, 2, 3, 4, 5, 6, and 7. Right? This is going to be the numbering. This is going to be the numbering. In the main chain, 7 carbon atoms. So what should I use? I should use hept. Should I use hept or hepta? There are 2 triple bonds in the main chain. So I should use hepta. Right? I should use hepta. Perfect. Now, at carbon number 2 and carbon number 4, 2, 4. 2, 4. It's going to be diene. There are 2 triple bonds, so di, and triple bond means ine. Hepta 2, 4 diene. Right? Look at the next one. Look at the next one. From where you are going to start the numbering? You'll start the numbering. See, maximum multiple bonds to be included in the main chain. So this has to be your main chain. Now, whether you are going to start the numbering from here or here, first locant should get the minimum number. Right? Then go for the lowest locant rule. Lowest sum rule. So you will find your numbering has to be from this side. 1, 2, 3, 4, 5, 6, and 7. Is this 7 actually? 1, 2, 3, 4, 5, 6, 7. Right? So at carbon number 3, you have got ethyl. So first you will write 3 ethyl. First of all, you will write 3 ethyl. Then it's going to be hept. It's going to be hept. Is it going to be hept or hepta? See, what do we have? We have got 2 triple bonds. We have got 2 triple bonds in the parent chain. Is it going to be hept or hepta? Is it going to be hepta? Right? Now, at carbon number 1 and carbon number 6, at 1 and 6, it's going to be diene. Diene. I believe it's clear to everyone. Right? I believe it's clear to everyone. Perfect, guys? Perfect. Look at this one. Look at this one. I told you in the beginning. First, always you will see the first locant has to get the minimum number. If you are unable to check from that, go to lowest sum rule. If you are unable to check from lowest sum rule, follow the alphabetical order. Correct? Follow the alphabetical order. Now, guys, try to understand what exactly I'm going to say. In the same carbon chain, you have got 2 types of bonds. Triple bond, double bond. Triple bond, double bond. Perfect. Follow the lowest locant rule. Right? First locant should get the minimum number. If I start the numbering from here, 1, 2, 3, 4, 5. Here the first locant is getting number 1. If I start the numbering from right to left, then it's going to be 1, 2. The first locant will be getting number 2. Right? So this is my correct numbering. Perfect. Now, guys, this is ene and this is ine. Right? This is ene, this is ine. Now try to understand. In the main chain, there are 5 carbon atoms. So it's pent. Here you are not going to write penta. Because 1 is double, 1 is triple. 1 is double, 1 is triple. Either both should be double or both should be triple. Then only you will write penta. Here 1 is double, 1 is triple. No penta here. No penta here. Right? So it's pent. Now, ene starts with E. Ine starts with Y. Alphabetically. Which one to prioritize? E comes first. E comes first, then comes Y. So I'll prioritize this first. So I'll write pent. 1. This is going to be ene. And at carbon number 3, you have got ine. You have got ine. But, my dear students, after E, a vowel sound is starting. A vowel sound I'm talking about. After E, a vowel sound is starting. Whenever after this E, vowel sound starts, you have to drop this E. You have to drop this E. So what has to be the name? What has to be the name? It is simply going to be pent. 1, in, 3, ine. This is going to be the name of the compound. As simple as that. Look at the next one. Look at the next one. Multiple bonds to be present in the main chain. So this is going to be your main chain. Now from where you are going to start the numbering? Will you start the numbering from here or here? Try to understand. Try to understand. From where you are going to start the numbering? Quickly, let me know. Let me know. My dear students, this is in here, this is in here. Perfect. E starts with E. See, the first locant, you cannot decide on the basis of first locant. You cannot decide on the basis of lowest sum rule. Now there is alphabetical order left. Now, this is ein, this is in. This starts with Y, this starts with E. So alphabetically E comes first. If E comes first, I'll be prioritizing this E. So 1, 2, 3, 4, and 5. Perfect. Now, look at this particular example. At carbon number 3, there is a propyl group. 1, 2, 3, 4. Sorry, butyl group. So at carbon number 3, you have got a butyl group. So carbon number 3, you have got butyl group. In the main chain, 5 carbon atoms. So it's going to be pent. It's going to be pent. This is in, this is ein. E comes alphabetically first. So it's going to be 1 in and 4 ein. But look at this particular scenario again. After E, vowel sound is starting. So drop the C. Simple. Simple, guys. I believe you can solve these sort of questions easily from now on. Perfect. I believe you can solve these sort of questions easily from now on. Okay. What is going to be the name of this one? I think we already did this or not. Are we done with this? No. Okay. Look at this particular molecule. What should be its name? First locant has to get the minimum number. This is carbon number 1. This is 2. This is 3. This is 4. This is 5, 6, 7, 8. So 8 carbon atoms in the main chain, right? So I'll be using the term oct. I'll be using the term oct. Should I use octa? I won't be using octa. For octa, there should be either 2 double bonds or 2 triple bonds, right? Perfect. It's going to be oct. Now, this is ein. This is in, right? This starts with E. This starts with Y. So I'll prioritize E. Alphabetically, it comes first. So it's going to be oct. Oct 6 in, 1 ein. 1 ein. After E, vowel sound is starting, so drop the C. Drop the C over here. Now look at this particular case. Look at this particular case. I believe you can easily solve this one. What do you think? What do you think is going to be the name? What do you think is going to be the name? Let's first of all see from here. 1, 2, 3, 4, 5, 6, and 7. The first locant is at carbon number 1, right? Perfect. Second locant is at 3. Third locant is at 6, right? If I start the numbering, opposite direction. This is 1, 2, 3, 4, 5, 6, and 7. The first locant is at 1. The second locant is at 4, right? The third locant is at 6. Is that? 1, 2, 3, 4. Here 1, 2, 3, 4, right? Now, first of all, go for the lowest sum rule. This is, see, first locant is same. Then go for the lowest. 6, 3, 9, 1, 10, right? 6, 4, 10, 1, 11, right? So prioritize the numbering from left to right. Prioritize the numbering from left to right. And when you do the numbering from left to right, you can easily name it then. Call this as 1, call this as 2, call this as 3, this is 4, this is 5, this is 6, this is 7, right? So it's first of all going to be hept. It's first of all going to be hept. Perfect. Now, my dear students, try to understand. Try to understand. This is in, this is also in, this is ein. So which one to prioritize? I'll be prioritizing E first. I'll be prioritizing E first. So it is going to be hept dash 1, 3 diene. 1, 3. It's going to be diene. 1, 3 diene. And at carbon number 6, you have got ein. So ein. After E, vowel sound is starting. So drop this E over here. Perfect. Simple. I believe you should be able to solve these sort of questions. Achha, by the way, I forgot to tell you one thing. Here you have got 2 double bonds. So should I be using hept or hepta? Right? 2 double bonds were there. So it's hepta. Perfect. Now talking about the cyclic compounds. In case of cyclic compounds, my dear students, you have to use the term cyclo first. In case of cyclic compounds, you have to use the term cyclo first. Right? Now see, since it is a closed ring, so use the term cyclo. Now how many carbon atoms do you have? 3. So it's going to be cyclopropane. Cycloprop, everywhere single bond, cyclopropane. Simple. So it's a closed ring, so it's cyclo. It's cyclo. In the ring there are 4 carbon atoms, so it's but, everywhere single bond, so it's cyclobutane, right? Now start the numbering from here. This is for example 1, this is 2, 3, 4, 5. It's going to be 1, 2 dimethyl, 1, 2 dimethyl, 1, 2 dimethyl. It's going to be then cyclo. In the main chain, 5 carbon atoms, so it's going to be pent. Everywhere single bond, so it's going to be ane. Right? So this is going to be the name of the compound. Simple. Right? Simple and basic. Simple and basic. Look at this one. Let's call this as carbon number 1. This is 2. This is 3. This is 4. This is 5. Since it's a closed ring, closed loop, it is cyclo first of all. In the chain, 5 carbon atoms, so pent. Right? At carbon number 1, there's a double bond, so it has to be ene. Simple. Right? Let's call this as 1, 2, this is 3, 4, 5, and 6. 1 and 2, 2 methyl groups. So 1, 2 dimethyl. 1, 2 dimethyl. Then it's cyclo. It is cyclo. In the main chain, 6 carbon atoms. So hex, 1 double bond at carbon number 1. So it's ene. Name of the compound. Done and dusted. Right? Done and dusted. Perfect, guys. Is it clear till here? Is it clear till here? Quickly. Is it clear till here? What should be the name of this particular compound? Let me know in the chats. What should be the name of the last compound? Let me know in the chats quickly. Let me see if you understood. Be careful. Here you have got ethyl. Here you have got methyl. Right? Quickly, guys, quickly. Whatever things I've told you till now, use the same. Done? Is it done? This is ethyl, this is methyl. Ethyl starts with E, so prioritize that. So this is 1, this is 2, this is 3, this is 4. Right? Right, guys? So what is going to be the name? Ethyl starts with E, methyl starts with M. I'll try to write ethyl first. So it's going to be 1 ethyl. It's going to be 1 ethyl, 2 methyl, 2 methyl. Then it's going to be cyclo. It is cyclo. In the main chain, there are 4 carbon atoms. So it is basically but. Everywhere there is a double bond. So it's going to be 1 and it's going to be ene. Perfect. This is going to be the name of the compound. Right? Right, people? I believe it's clear. I believe it's clear. Try to name this particular compound in the similar process. This is 1, this is 2, this is 3. 1, 2 dimethyl. 1, 2 dimethyl. Right? 1, 2 dimethyl. Then it's cyclo. It is cyclo. Main chain contains 3 carbon atoms, so it's prop. There is a double bond at carbon number 1, so it's ene. Done and dusted. Right? Done and dusted. Look at this particular one. Start the numbering from wherever you want. This is 1, this is 2, this is 3, this is 4, this is 5, this is 6. So it's first of all cyclo. It is hex. Should I write hex or hexa? 2 double bonds. So it's hexa. It is hexa. 1 and 4. It's going to be 1, 4. It's going to be diene. This is going to be the name of the compound. Right? Look at the next one. Okay, what do you think here? Which one should I treat as the main chain? Should I consider this one as the main chain or this one as the main chain? Should the linear one be the main chain or cyclic one be the main chain? What do you think? What do you think? What do you think? What do you think? My dear students, count the carbon atoms in this particular one. 1, 2, 3, 4, 5. Okay. In this one, 1, 2, 3, 4. More the carbon atoms, the one you are going to select. Right? So which one you are going to prioritize? The linear chain you are going to prioritize because it contains more carbon atoms. This one contains less carbon atoms. Right? So here what you can exactly do is, this is 1, this is 2, this is 3, this is 4, this is 5. At carbon number 2, it is a cyclobutyl group. At carbon number 2, it's going to be cyclobutyl. And then it's going to be in the main chain 5 carbon atoms. Then it's going to be pent. Everywhere it's a single bond. It's going to be pentane. Done and dusted? Yes. Okay, what about this one? Among these two rings, which one to prioritize? Which one to prioritize? That ring which contains more carbon atoms. So this is the ring containing more carbon atoms. This is my parent chain over here. Correct? 2. This is 1. Let's call this as 2. This is 3. This is 4. This is 5. This is 6. At carbon number 1, you have got cyclopropyl. At carbon number 1, it is cyclopropyl group. Cyclopropyl group. In the main chain, 6 carbon atoms. So first of all, main chain is cyclic in shape. So it is cyclohex. Everywhere there's a single bond. So cyclohexane. Right? Yeah? Done. Look at this one. Which one to prioritize? This one or this particular one? 1, 2, 3. 1, 2, 3, 4. Here you have to prioritize this. 1, 2, 3, 4. Perfect. Now guys, try to understand. You have selected your parent chain. Now in this parent chain, should I be calling this as simple substituent or complex substituent? Tell me quickly in the chats. Is this the simple substituent or complex substituent? Quickly. Let me call this as 1. Let me call this as 2. Right? At carbon number 1, and after that, I'll write 1 methyl and it's going to be ethyl. 1 methyl, 1 methyl ethyl. 1 methyl ethyl. Done? Then this ring is cyclic. So it's cyclo. It is cyclo. How many carbon atoms? 4. So it's but. Everywhere, single bond. Butane. Done and dusted? Done and dusted, people? I believe these sort of questions you should be able to solve from now onwards. These various cyclic compounds. Right? See how easily we are doing the things. Slowly, level will increase. Slowly, level will increase. Now we are going to talk about the Spiro compounds. Have you heard about Spiro once? Have you ever heard about Spiro compounds? Whenever you see this particular compound, right? Two rings having 1 carbon atom in common. 2 rings having 1 carbon atom in common. You'll be calling this compound as the Spiro compound. This is your Spiro compound. This particular carbon over here is something which I call as spirocarbon. This is something which I call as spirocarbon. The way in the cyclic compounds we start with cyclo. Similarly, in case of spiral compounds, in case of spirocyclic compounds, you start with the term spiro. Let's have a look. How do we name it? See, when 2 rings are attached at a single carbon atom, right? That's something which you call as spirocarbon. Such compounds are called as spirocyclic compounds. Have a look, people. How do we name it? How do we name it? It's the Spiro compound. It's understood. 2 rings attached. 2 rings which have got 1 atom in common. 2 rings, 1 atom in common. First thing. How do we do the numbering in these compounds? That's important. Okay, if that is important, try to understand carefully. My dear students, you have got 2 rings here. This is 1 ring, this is 1 ring. Okay. Now, first of all, tell me which one is the smaller sized ring. I would say this is the smaller sized ring. In case of Spiro compounds, you will start the numbering always from the smaller sized ring. In the Spiro compounds, you will start the numbering always from the smaller sized ring. So I have to start the numbering from the smaller sized ring. But do not start with the spirocarbon. That carbon which will be adjacent to spirocarbon, start from there. So this is 1, this is 2, this is 3, 4, 5, 6, 7. Done? Look here. You have got again 2 rings. How many carbon atoms in this one? 1, 2, 3. Apart from spirocarbon, 3 carbon atoms. 1, 2, 3, 4. 4 carbon atoms. Which one is the smaller size? This one is smaller size. Start the numbering from the smaller size. Not from the spirocarbon, the carbon that's adjacent to that. So this is 1, this is 2, this is 3, this is 4. Calling this is 5, this is 6, this is 7, this is 8. Right? Numbering is done. Now, after the numbering is done, I'll be starting with Spiro. Right? Spiro. Bracket on. In the smaller sized ring, except the spirocarbon. How many carbon atoms are there? 2. 2, comma. In the larger sized ring, except the spirocarbon, how many are there? 1, 2, 3, 4. So 2, 4. 2, 4. Total in the main chain, 7 carbon atoms. So it's hept. Everywhere there's a single bond, it's in. Dusted. Right? Look at the next one. Look at the next one. First, I'll start with Spiro. I'll start with Spiro. Right? Then bracket on. In the smaller size ring, 1, 2, 3. In the larger size ring, 1, 2, 3, 4. 4 carbon atoms. Total how many atoms? 8. So it's oct. Everywhere single bond. Octane. Are you getting this? Are you getting this? Are you getting this, people? Look at this one. Look at this one. Look at this one quickly. First of all, there's the spirocarbon. I'll start from that ring which is smaller in size. 1, 2, 3. 1, 2, 3, 4. I'll start from here. Let's call this as 1, calling this 2, 3, 4. This is, for example, 5. This is 6. This is 7. This is 8. Perfect. I'll be starting with the term Spiro. I'll be starting with the term Spiro. Now, people, in the smaller size ring, how many atoms? 1, 2, 3. 3 carbon atoms, comma. Larger size ring, 1, 2, 3, 4. 3, 4. Perfect. In the main chain, how many carbon atoms? 8. So oct. There is a double bond here. 6. It's ene. Right? Right, people? Right? Look at the next one. Start from the smaller size ring. Let's call this as 1, this is 2, this is 3, this is 4. Calling this 5, 6, 7, 8. First of all, it is 5, 6 diethyl, right? First of all, it's 5, 6. 5, 6 dimethyl, sorry. 5, 6 dimethyl, right? Now it's Spiro. Now it's Spiro. In the smaller size ring, 1, 2, 3. In the larger size ring, 1, 2, 3, 4. 3, 4. 3, 4. In the main chain, 8 carbon atoms. So oct. Everywhere is a single bond. So it's ene. Done? Done, guys? I believe it's clear. The next one. The next one. See, both the rings are similar in size. Both the rings are similar in size. One is substituted, one is not. Right? One is substituted, one is not. So I'll start with the one which is substituted. Let me call this as carbon number 1. This is 2, this is 3, this is 4. This is 4. Let's call this as 5, this is 6, this is 7. So it is first of all 1, 2 dimethyl. 1, 2 dimethyl. 1, 2 dimethyl. Then you write Spiro. Then you write Spiro. Right? Then you write Spiro. 1, 2, 3. 3, 3. 3, 3. 3, 3. In the main chain, 7 carbon atoms. So it's hept. Everywhere it's a single bond. So it's ene. Right? Correct, guys? Look at this one. Start the numbering from that ring which is smaller in size. Which one is smaller in size? Have a look. 1, 2, 3, 4. 1, 2, 3, 4, 5. This one is smaller in size. Let me start from here. This is carbon number 1. This is 2. This is 3. This is 4. 5, 6, 7, 8, 9, and 10. Perfect. Now at carbon number 2, you've got a methyl. At carbon number 2, you've got a methyl group. So 2 methyl. Perfect. Now it's a Spiro compound. So write Spiro. Right? In the smaller size ring, 1, 2, 3, 4. In the larger size ring, 1, 2, 3, 4, 5. 5 carbon atoms. In the main chain, 10 carbon atoms. So it's dec. Everywhere, there is not a single bond. There is a double bond here. Right? So it's dec. So it's dec. At carbon number 1, it's ene. Right? People, can you solve these sort of questions from now on quickly? Yeah? Right, people? Okay, guys? I mean, are you getting all the things clearly? Are you getting all the things clearly? Look at this one. Start with the smaller size ring. 1, 2, 3, 4. This is 5. This is 6. This is 7. This is 8. Perfect. So first you will be starting with the term Spiro. Then in the smaller size ring, 1, 2, 3. So it is 3, larger size ring, 1, 2, 3, 4. So 3, 4. 3, 4. In the main chain, total 8 carbon atoms. So it's oct. Right? At carbon number 6, there is a double bond. So oct 6 ene. Oct 6 ene. right? Opt 16. The next one. The next one. Which one to prioritize? Smaller size ring to prioritize. 1, 2, 3, 4. 1, 2, 3, 4, 5. Right? Start from here. 1, 2, 3, 4, 5. Now, is this going to be 6 or this is going to be 6? Since this is substituted, so this is going to be 6, 7, 8, 9, 10. So it's going to be, first of all, have a look. This is ethyl group, this is methyl group. Ethyl starts with E, methyl starts with M. So it's going to be 6 ethyl. It's going to be 6 ethyl, 7 methyl. 6 ethyl, 7 methyl. Then it's the Spiro compound. So Spiro. 1, 2, 3, 4. 4 carbon atom in the smaller ring. 1, 2, 3, 4, 5. 5 carbon atoms in the larger ring. Right? In the main chain, total 10 carbon atoms. So it's dec. Everywhere it's a single bond. So decane. Right? Right, people? Right, guys? Buddha Surya. Sir, Bicyclo and Spiro compounds with functional groups and multiple bonds are out of syllabus. Bro, since you know that your syllabus got reduced, now they got to increase the level of the paper so they can ask anything, right? They have not mentioned in your syllabus that this is deleted. Perfect. This is normal NEET level. It is your now going to be the NEET level. Be careful with all this, whatever I'm saying. It is now going to be your NEET level. Okay? Because the level of the NEET paper has to be tough. Right? And this is basic stuff, guys. This is basic. Remember one rule and kill it. That's it. What is there to think? Yeah? Perfect. Okay, let's move ahead. Let's move ahead. Now Spiro is done. Have a look on Bicyclo. Have a look on Bicyclo. Right? Have a look on Bicyclo. And anyways, if they do not ask question from Spiro Bicyclo, what is wrong? It's a free class. You're not paid for it, right? Yeah. That was rude, I think. Was that rude from my side? I say it. It's okay. I don't take things seriously. Let's start with GOC first. It's a first lecture, guys. Just wait for it. Slowly, slowly, you'll see the other chapters too. No issues. Okay? All right. Okay, now we have got bicyclo compounds. We have got bicyclo compounds. My dear students, there is a special way of naming bicyclo compounds. Now, first of all, what are bicyclo compounds? Let's have a look. This is your bicyclo compound. Look at the definition. Bicyclo compound. It consists of two fused rings. This is one ring. This is one more ring. Both the rings have got two atoms in common. Both the rings have got two atoms in common. Whenever you see such kind of the rings, in which two atoms will be common to two rings, right? Perfect. In which two atoms will be common, the rings will be fused. You'll be calling it as a bicyclo compound. Now the point is, how do we name the bicyclo compound? That's important. Try to understand how do we exactly name the bicyclo compound. See, first of all, how do we do the numbering first of all? How do we do the numbering? My dear students, this carbon and this carbon, which is common to both the rings, you call these carbons as the bridged carbons. You call them as the bridged carbons. Okay. Now, first of all, from where and how exactly you're going to start the numbering? You'll be always starting the numbering from the bridgehead carbon. From the bridgehead carbon, either from here or from here. So it's carbon number 1, for example. Right? It's carbon number 1. Now, which ring is bigger in size? This particular ring is bigger in size. That ring which is bigger in size, that has to be prioritized. So this is 2, this is 3, this is 4, this is 5, this is 6. Now this is 7, this is 8. I hope till here it's clear. I hope till here it's clear. Right? I hope till here it's clear. Now, I'll be using the term bicycle. I'll be using the brackets. I'll be using the brackets. Now, if I ask you something like this, for example, in order to move from carbon number 1 to carbon number 6, in order to move from this bridgehead carbon till this bridgehead carbon, how many paths are available to me? I can choose this path to go from 1 to 6, to go from one bridgehead to another bridgehead. I can choose this particular path, or I'll directly come from 1 to 6. So how many paths are there? 3 paths. 3 paths are there, right? 3 paths exactly are there. One is the longest path. One is the longest path. One is shorter path. And the middle one, it is the shortest path. Right? Longest, shorter, shortest. Now, tell me how many carbon atoms do you see in the longest path? Except the bridgehead carbons. 1, 2, 3, 4. Write 4, comma. Shorter path. 1, 2. Right? Shortest path. There is no carbon atom in the middle. So 4, 2, 0. Right? Total how many carbon atoms? 8. Or everywhere single bond. 8. Done and dusted. Understood? For example, look at another one. Look at another one. Look at another one, people. Look at another one. Have a look properly. These two are your bridgehead carbons, right? These two are your bridgehead carbons. Now follow the paths. One path is this, one path is this, one path is this, right? Now guys, over here, try to understand one simple thing. One simple thing. All the rings, they have got equal size basically. So start from the bridgehead carbon, for example, from here, right? This is 2, this is 3, this is 4, this is 5, this is 6. Now this is 7, this is 8. Okay. Now you'll be writing first of all Bicyclo. Bicyclo. All the paths are same. This is one path, this is second path, and this is your third path. Right? In all the paths, 1, 2, 1, 2, 1, 2. It's going to be 2, 2, 2. Perfect. In the chain, I mean, how many total carbon atoms are there? 7. So it's going to be hept. Everywhere it's a single bond. So heptane. I hope you're understanding all these things. Okay. The next one. The next one. The next one, guys. The next one. Okay. This again the Bicyclo compound. These are your bridgehead carbons. These are your bridgehead carbons. Now, which ring you have to choose? The larger size ring. Calling this as carbon number, calling this as carbon number 1. This is 2, this is 3, this is 4, this is 5, this is 6, 7 and 8, right? So first of all, 7, 8, 2 methyl groups. So 7, 8 dimethyl. 7, 8 dimethyl, right? Then you'll be using the term Bicyclo. You'll be using the term Bicyclo. Now, from 1 to 6, longest path, shorter path, shortest path. In the longest path, how many carbon atoms? 1, 2, 3, 4. So far, 4 carbon atoms. In the shorter path, 1, 2, 2 carbon atoms. In the shortest path, no carbon atom in the middle. So 4, 2, 0. Since there are 8 carbon atoms, so it's oct. Everywhere it's a single bond, so it's ane. Done and dusted. Right? Done with this. Done with this. Done with this. Okay, look at this one. I believe you can easily solve them now. Okay, start with the bridgehead. So this is 1. Okay, longest path. 2, 3, 4, 5, 6, 7. And this is 8. This is one more bridgehead. Right? So I'll be using the term Bicyclo. Bicyclo. In the longest path, 1, 2, 3. 3 carbon atoms. In the shorter path, 1, 2. 2 carbon atoms. In the shortest path, 1 carbon atom in the middle. Right? How many carbon atoms in total? Oct. 8 carbon atoms everywhere single bond. So it's ane. Right? It's ane. Chalo, the next one. These are your bridgeheads. These are your bridgeheads. Now, this is 1, this is 2, this is 3, this is 4, for example. So first of all, you'll write Bicyclo. You'll write Bicyclo, right? This path and this path, they're same. So it's 1, 1, in the middle, there is no carbon, 0. And it's going to be Bicyclo 1, 1, 0. It's going to be but. Everywhere there is a single bond, so it's ane. Perfect. Now, start from the bridgeheads. So carbon number 1. Let's call this as carbon number 1. Now after this particular path contains 2 carbon. This particular path again contains 2 carbon. Which one to prioritize? This one is substituted 2. So calling this 2, 3, 4, 5, 6, and this is 7. So it's 2, comma 3. It's 2, comma 3 dimethyl. 2, comma 3 dimethyl. Okay, it's 2, comma 3 dimethyl. Then you'll be writing the term bicyclo. Bicyclo. This path contains 2 carbon atoms. This particular path contains 2 carbon atoms. This particular path contains 1 carbon atom. So it's 2, comma 2, comma 1. Right? And in the main chain, how many? 7 carbon atoms. So it's hept. Everywhere it's a single bond. So it's heptane. Are you understanding all these things? Are you able to understand all these things? Clearly? Clearly, I mean? Clearly? Okay. If everything is clear till here, let's move on to next one. Moving on to next one. Again, a bicyclo compound. This is one. I mean, these are the bridgeheads. This path contains 2. This path contains 1, 2 carbon atoms, right? So I'll be prioritizing this 1, 2, 3, 4, 5, 6, and 7, right? So first of all, I'll write bicyclo. It's a bicyclo compound. Perfect. Here, carbon atoms. Here, 2 carbon atoms. Here, 1 carbon atom in the middle. So 2, comma 2, comma 1. In the main chain, there are 7 carbon atoms, so it's hept, right? At carbon number 2, there's a double bond, so it's hept to ene. Done and dusted, right? So look at your bridgeheads. These are your bridgeheads. Perfect. Start, for example, from here. Now, this path contains 1, 2 carbon atoms. This path contains 2 carbon atoms. Which one to prioritize? The one which substituted. So 2, this is 3, 4, 5, 6. So it's going to be 2, comma 3. 2, comma 3 dimethyl. 2, comma 3 dimethyl. Then you'll write the term bicyclo. Bicyclo. So 2, 2, 0, right? 2, 2, 0. And it's going to be 6 carbon atoms in total, right? So it's going to be hex. Everywhere is a single bond. So hexane. Perfect, guys? Okay, the next one. The next one. Both the rings are equal in size. Both the rings are equal in size. Let me start from here. 1. This is 2. This is 3. This is 4. This is 5. 6, 7, 8, 9, 10. So 3, comma 4 dimethyl. 3, comma 4 dimethyl. Number 1. Okay. After that, bicyclo. After that, bicyclo. This path, equal in size, right? Okay. 1, 2, 3, 4. Even 1, 2, 3, 4. In the middle, there is no carbon atom. So 4, 4, 0. 4, 4, 0. In the main chain, 10 carbon atoms. So dec. At carbon number 3, there is a double bond. So dec 3ene. Dec 3ene. Perfect. Right, guys? So I believe these sort of questions can be easily solved from now on. Okay, look at this one. Look at this particular one. Look at this particular one. All right, guys. So this is your bridgehead carbon. This is your bridgehead carbon. Perfect. This path contains 2 carbons. This path also contains 2 carbons, 1, 2. But this one is substituted, right? So let's call this is 1, this is 2, this is 3, this is 4, 5, 6, and in the middle it's 7, right? So 2, comma 3 diethyl. 2, comma 3 is going to be diethyl. Sorry, dimethyl. 2, comma 3 dimethyl, right? Now I'll be using the term bicyclo. Bicyclo, right? Now, here 2 carbon atoms, here 2 carbon atoms, in the middle 1 carbon atom. So 2, comma 2, comma 1. 2, comma 2, comma 1. In the main chain, how many carbon atoms? 7 carbon atoms. So hept. It is hept. Now, in the main chain, there are 2 double bonds. So it has to be hepta. It has to be hepta. 2, comma 5. Hepta. 2, comma 5. It's going to be diene. It's going to be diene. I believe this is also clear to everyone. Okay. So with this people, we are done with alkanes, alkenes, alkynes, cyclic, Spiro, and bicyclo, right? Let's take a break for 15 minutes. Get back and we'll see the compounds containing functional groups, right? So the time right now is 2021, right? 2021. I'll have a tea basically, so because throat starts aching. Okay. So what time you'll get back? But I would want every one of you to be back, guys. I would want everyone, every single one of you to be back. What time? I'll see you at 8:45. Okay? Session resumes at 8:45 p.m. Okay? I would want every one of you to be back. Every one of you to be back, because we have to complete this, guys. We have to complete this. Otherwise, it's not going to be fun. And if you won't be back, then your organic chemistry will be stopped here only. Right? This is Thamki from my side. See you in a while, okay? See you in a while. What's up, people? Can you all hear me? Am I audible, visible? Audible, visible to everyone? Quickly, let me know in the chats if all of you can again hear me, if I'm perfectly audible, visible to every one of you. Yes, can you all hear me? Just a second, guys. Just a second. Okay. All right. So, all ready again? I think everyone got back. By the way, so, like I was saying your chats, people were asking about the Avenger 3.0 batch. It's not at 8,500. It's only at 3,999, right? 3,999 only is the cost of it. Link is there in the description box. You just have to use the code WASSIM10. You'll get the lot of discount and you'll be getting the batch exactly for 3,999. Okay, and it started yesterday only. Okay, so should we start, people? Are you all ready now? Are you all ready now? Are you all ready now? Say yes or no in the chats. We are just going to take almost like 1 hour more. Yeah. And we are done. Yes, I'll be teaching isomerism also. Yes, I'll be doing that. I'll be teaching isomerism also. Perfect, guys. So let's get to know, like, how do we name those compounds which contain functional groups, right? The first functional group which we are going to discuss right now, that is going to be your carboxylic acid. Carboxylic acid, COOH group. This group is what you call as carboxylic acid, right? C double bond O, OH. I hope this is something which you already know. This is how. This is your basically what? This is your carboxylic group. My dear students, I would want you to remember only 2 to 3 things over here. I would want you guys to remember just 2 to 3 things over here. And what are those 2 to 3 things exactly? Have a look. I am going to talk about those compounds which contains the functional group carboxylic acid. Now, 3 things you have to remember over here. My dear students, as a suffix, basically, as a suffix, when we have to use carboxylic acid as a suffix, either you'll be using the term oic acid, or you'll be using the term carboxylic acid. When you treat carboxylic acid as suffix, basically, when you have to write it as suffix, either you'll be writing oic acid at the end, or you'll be writing carboxylic acid at the end. Now, when to write oic acid, when to write carboxylic acid. Do remember, when the carbon of the carboxylic acid, is the part of the main chain, is the part of the parent chain, at that point of time, the suffix used for carboxylic acid is oic acid. Okay? And if the carbon of the carboxylic acid is not the part of the main chain, the suffix which we need to use, that is directly going to be carboxylic acid at the end. You'll get to know in some time what that means. And similarly, as a prefix, we use the term carboxy for carboxylic acid. We use the term carboxy for the carboxylic acids. Let's have a look exactly what it means. By the way, on this channel, we never used to have the spammers. Who is this Murthy? PW. What do I have to do with PW, guys? Why are you writing the name PW here in the chats? Out of your sense? Why are you writing it here? Let people study, right? Let people get benefited from everywhere, whatsoever platform it is. Anyways, everyone is in the free sessions only, be it this platform, some other platform. Yeah, or you're the paid user or something. Okay, perfect, guys. Try to understand. So two things I told you. Carboxylic acid as a suffix, you'll be either using oic acid or you'll be using carboxylic acid, right? As a prefix, you'll be using carboxy. Now try to understand. Look at this particular compound over here. If you look at this particular compound properly, this is your COOH group. This is C double bond OH. This is the carboxylic group here. Perfect. Now, my dear students, just start the numbering. Start the numbering. Call this carbon number 1, this is 2, this is 3, this is 4. So the word root has to be but. Everywhere it's a single bond. So it is butane. Butane. Right? The carbon of the carboxylic acid is the part of the main chain. It is the part of the main chain. Right? It is a part of the main chain. It is the part of the main chain. Correct? It is the part of the main chain. Perfect. So what should I use? Butane, it's 1 oic acid. It is 1 oic acid. Now tell me one thing. After this E, a vowel sound is starting. Drop this E. Drop this E over here. Perfect. It's just give me a second. Just a second, people. Just a second, just a second. Just a second. Guys, just a second, okay? Just give me a second. Just a second. Yes, yes. Just a second. Let me import the file. It'll take a minute. It'll take a minute. It will take a minute. Uh, just a minute, guys. Just a minute. Wait, I'll have to reload the slides again. I had by mistakenly used the previous slide. You got what I'm talking about, right? Mistakenly, I have used the previous slide. Just a second. I know you won't have any problem, but I'll have problem, right? I'll have problem. Just wait for a minute. And please don't write it in the comment section, okay? I'll be killed. Wow, states of matter. This looks better now. This looks better. Okay, let's move on, guys. Let's move on. Let's move on now. All right. So first of all, I told you for the carboxylic acids, you have to remember three things. As a suffix, you'll be either using oic acid or you'll be using carboxylic acid. If the carbon of the carboxylic acid is the part of main chain, the suffix used is oic acid. If the carbon of the carboxylic acid is not the part of main chain, the suffix used is carboxylic acid. And if we have to take carboxylic acid as a prefix, then we'll be using the term carboxy. Carboxy. Try to understand. Try to understand. Have a look. Let me start the numbering over here. This is 1, this is 2, this is 3, this is 4. So in the main chain, there are 4 carbon atoms. So word root has to be but. Everywhere it's a single bond, so it's ane. At carbon number 1, you will be writing, since there is a carboxylic acid over here, so you will be writing oic acid. Why oic acid, people? Why oic acid? Because carbon of the carboxylic acid is the part of main chain. Now after this E, vowel sound is starting, so drop the C. Right? This is going to be the name of the compound. Look at the next one. Look at the next one. Calling this is 1, this is 2, this is 3, this is 4. So at carbon number 2, you have got 2 methyl groups. So it is 2, 2 dimethyl. 2, 2 dimethyl. 2, 2 dimethyl. Now, in the main chain, 4 carbon atoms. So but. Everywhere it's a single bond. Butane. And over here, as you can see, it is carboxylic acid. The carbon of the carboxylic acid is the part of the main chain. So it's going to be 1, suffix used is oic acid. Right? Suffix used is oic acid. After E, vowel sound is starting. So drop this E over here. Okay? Now, 1, 2, 3, and 4. Perfect. So first of all, the word root is going to be but. Everywhere is a single bond. So it's butane. Right? 1 and 4. 1 and 4. 1 and 4. 1 and 4. There are 2 carboxylic acids. COH. This is COOH. Right? 2 carboxylic acid groups. Perfect. So I'll be using the term di. I'll be using the term di. Now tell me one thing. Tell me one thing. Whether the carbon of these carboxylic acids is the part of main chain. Yes, they are the part of main chain. So it's dioic acid. It is dioic acid. I believe you can do these sort of questions easily from now onwards. Moving ahead. Moving ahead. Look at this particular thing. This particular one is important, guys. This particular compound is important. See, this is your carbon, carbon, carbon. This is your C double bond OH. This is your C double bond OOH. This is your C double bond OOH. So 3 carboxylic acid groups are attached. 3 carboxylic groups are attached, right? Do remember one simple rule, my dear students. Whenever you have got more than 2, same groups, same functional groups, starting with carbon, and directly attached to the chain, none of these carbons of the carboxylic acids is to be included in the main chain. None of the carboxylic acids is to be included in the main. None of the carbon of the carboxylic acids is to be included in the main chain. So what I'm trying to say, do not do the numbering here as 1, 2, 3, 4, 5. Do not do that. Because there are 3 carboxylic acids. There are 3 functional groups which are starting with carbon. And all those carbons of carboxylic acids are directly attached to the chain. none of the carbon of the carboxylic acid is to be considered in the parent chain. So let me call this as 1, let me call this as 2, let me call this as 3, right? So once it's done, now what you'll be writing? You'll be writing propane, because single bond everywhere, propane, it is going to be 1, 2 and 3. Propane 1, 2, 3. None of the carbon of the carboxylic acid is the part of the main chain. It's going to be tricarboxylic acid. Tricarboxylic acid. Tricarboxylic acid. Look at the next one. Look at the next one, people. Have a look. This is carbon number 1, 2, 3, 4, 5, 6. Again, 3 carboxylic acids directly attached with the parent chain. None of the carbon of the carboxylic acid none of the carbon of the carboxylic acid is to be considered in the parent chain. Perfect. Now, it is cyclohexane basically. This is cyclohexane. This is cyclohexane at 1, 2 and 4. At 1, 2 and 4. What you'll be writing? Since none of the carbon of the carboxylic acid is the part of the main chain, so it's going to be 1, 2, 4 and it's going to be tricarboxylic acid. Tricarboxylic acid. Perfect. Tricarboxylic acid. Look at the next one. Look at the next one. It is a bicyclo compound. It is a bicyclo compound. So you start the numbering from the bridgehead carbon. Perfect. From the bridgehead carbon. Now, what do we have to do? Should we prioritize the bigger ring or smaller sized ring? I'll be prioritizing the bigger sized ring first in the bicyclo compounds, if you remember. Let's call this as carbon number 1. This will be 2. This will be 3, 4, 5, 6, 7, 8, 9 and 10. Perfect. So it's a bicyclo compound. I'll use the term bicyclo first, right? Now, this is the bigger size ring containing 1, 2, 3 and 4 carbons. So 4, comma. Smaller size ring 1, 2, 3, 4, right? 1, 2, 3, 4. Anyways, they are of equal size. So 4, 4, comma, right? In between the shortest path, there is no carbon. So 4, 4, 0. So bicyclo 4, 4, 0. Now, how many carbon atoms in the main chain? 10. So it's going to be dec. Everywhere it's a single bond. Decane. At 3 and 4. At 3, 4. There are 2 carboxylic acids. None of the carbon of the carboxylic acid is the part of main chain. So it's going to be 3, 4. Dicarboxylic acid. Dicarboxylic acid. I hope this is clear to everyone. Look at the next one. Look at the next one. Let me call this as carbon number 1. This is 2. This is 3. This is 4. This is 5. This is 6. Right? Now, my dear students, if you understand, if you look at this particular compound carefully, at carbon number 2, it's a complex substituent. It's a complex substituent. Right? It's a complex substituent. So first of all, you will say at carbon number 2. At carbon number 2. This is 1 here. You will start the numbering here also. This is 1. This is 1. Now, this COH, it will be taken as a prefix. And when COOH taken as a prefix, it's carboxy. So it is written as, it is written as 1 carboxy methyl. 1 carboxy methyl. Perfect. Then it is going to be a cyclohexane. Cyclohexane at 1 and 2. These two are the carboxylic acids and none of their carbons is the part of the main chain. So cyclohexane, this is going to be 1, 4. It's going to be dicarboxylic acid. Dicarboxylic acid, right? Look at the next one. The next one is Spiro compound. The next one is Spiro compound, right? In the Spiro compounds, which ring do we need to prioritize first? The one which is smaller size ring. The one with smaller size ring. 1, 2, 3. 1, 2, 3, 4. This is the smaller size ring. So call this as 1. This is 2. This is 3. This is 4. This is 5. This is 6. This is 7. This is 8. Now, I'll be first of all writing Spiro. I'll be writing Spiro. In the smaller size ring, 1, 2, 3. 3 carbon atoms. In the larger size ring, 1, 2, 3, 4. 4 carbon atoms. So 3, 4. In the chain, there are 8 carbon atoms. So it's oct. Everywhere it's a single bond. So it's octane. At carbon number 6, there is a carboxylic acid. Carbon of the carboxylic acid is not the part of main chain. So it is 6 carboxylic acid. 6 carboxylic acid. I believe this is clear. I believe this is clear. I believe this is clear. Right? Moving ahead. Let's talk about those compounds which have got the cyanide functional group, CN. This is the functional group now, C triple bond N. C triple bond N. This is the cyanide functional group. Here again you have to remember three things. As a suffix, you'll be using either nitrile or you'll be using carbonitrile, depending on whether the carbon of cyanide group is the part of main chain or not. If the carbon of the cyanide group is the part of main chain, then the suffix used is nitrile. If the carbon of the cyanide group is not the part of the main chain, then the suffix used is carbonitrile. Carbonitrile. And if CN has to be used as a prefix, then we'll be using the term cyano. We'll be using the term cyano. Let's do certain examples. Nitrile, carbonitrile, cyano. Nitrile, carbonitrile, cyano. Try to understand. First of all, this is your carbon number 1, this is 2, this is 3. Perfect. So now, what is going to be the name? The name is simply going to be 2-methyl. At carbon number 2, you have got a methyl group. So it is 2-methyl, right? In the main chain, 3 carbon atoms, 2-methyl prop, everywhere single bond. So it's N and this is CN group. This is CN. Now, carbon of cyanide is the part of main chain. Suffix used has to be nitrile. So 1-nitrile. 1-nitrile, right? 1-nitrile. Yes. Look at this one. Look at this one. Start the numbering from here. 1, 2, this is 3, this is 4. So it's going to be 3,3-dimethyl. It is 3,3-dimethyl. It is 3,3-dimethyl. In the main chain, 4 carbon atoms. So it is but. Everywhere there is a single bond, so it's ane. Now, this is the functional group, and the carbon of this cyanide is the part of main chain. So the suffix used is nitrile. Butane 1-nitrile. Butane 1-nitrile. Right? Look at the next one. This is 1, 2, 3, 4, 5, and 6. So it is going to be cyclohexane. It is going to be cyclohexane. The carbon of cyanide is not the part of the main chain. The suffix used has to be carbonitrile. So cyclohexane 1-carbonitrile. 1-carbonitrile. I hope this is also done and dusted. Right? Look at the other examples. Let's call this as 1, this is 2, this is 3, 4, 5, and 6. Right? So first of all, it is cyclohexane. It is cyclohexane. At carbon number 1 and carbon number 2, there are functional groups. Cyanide. None of the carbon of cyanide is the part of the main chain. Right? So it's going to be cyclohexane 1, 2. I'll write di. Should I use nitrile or carbonitrile? I'll be using the term carbonitrile because none of the carbon of cyanide is the part of the main chain. Perfect. Look at the next one. Bicyclo compound. Same sized rings. But this ring is substituted. Right? It contains the functional group. So prioritize this one. Calling this is carbon number 1, this is 2, this is 3, 4, 5, 6, 7, 8, 9, 10. Right? So I'll be using the term bicyclo. It is the bicyclo compound. Now, 1, 2, 3, 4. 1, 2, 3, 4. In the middle, 0. So 4, 4, 0. 4, 4, 0. 10 carbon atoms in total. So it is dec. Everywhere is a single bond. So it's an ane. At 3 and 4, 2 functional groups. None of the carbon of the functional group is the part of the main chain. Suffix used has to be carbonitrile. But it is going to be 3, 4 dicarbonitrile. 3, 4 dicarbonitrile. Look at this particular compound. It's a Spiro compound. In the Spiro compound, we start with the lesser membered ring. 1, 2, 3. 1, 2, 3, 4. Right? So start the numbering, not from the Spiro carbon. The carbon adjacent to that. Calling this as 1. This is 2. This is 3. This is 4. Right? Now it's simple. 5, 6, 7, 8. So write the term Spiro first. In the smaller sized ring, 1, 2, 3, 3 carbon atoms. In the larger sized ring, 1, 2, 3, 4, 4 carbon atoms. Right? In the main chain, 8 carbon atoms. So it's oct, everywhere it's single bond, octane. At carbon number 6 and 7, 2 functional groups. So 6, 7. It's going to be di. None of the carbon of the functional group is the part of the main chain. So it's going to be carbonitrile. It is going to be carbonitrile. I believe it's clear. I believe it's clear. I believe it's clear. Right? I believe it's clear. Few more. Few more. Few more. Calling this as 1, this is 2, this is 3, this is 4, this is 5, this is 6. Now guys, here you have got a complex substituent. In the complex substituent, you'll again start the numbering. Let's call this as 1. Calling this as 1. Right? So I'll be using this one as the prefix. Right? Now, first of all, at carbon number 2. At carbon number 2, there's a complex substituent. Right? This cyanide, I'll be using prefix for it. Prefix for it is cyano. So it is cyanomethyl. It is 1 cyanomethyl. 1 cyanomethyl. Then it's the cyclohexane. Then it's the cyclohexane. It's the cyclohexane. At carbon number 1 and 3, there are 2 functional groups. None of the carbon of these functional groups is the part of main chain. So I'll be using dicarbonitrile. Dicarbonitrile. Did you get this one? Did you get this one? Now, look at this particular one. It's a bicyclo. It's a bicyclo. Start the numbering from the bridged carbon. So let's start from here. Let's start from here. Perfect. Starting from here. Now guys, try to understand. 1, 2, 3, 4. 1, 2, 3, 4. Both are equal sized rings. Both are equal sized rings. But this one is substituted as well as contains double bond. So prioritize it. So this is 1, this is 2, this is 3, 4, 5, 6, 7, 8, 9, and 10. Right? So I'll be first of all using bicyclo. It's a bicyclo compound. Bicyclo. Now tell me. 1, 2, 3, 4. 1, 2, 3, 4. In the middle, no carbon atom. So 4, 4, 0. In the main chain, 10 carbon atoms. So it's dec. At carbon number 3, there is a double bond. So decene. Decene. Perfect. Decene. At 3 and 4. At 3 and 4. At 3 and 4. There are 2 functional groups. At 3 and 4. There are 2 functional groups. Perfect. Which one? Cyanide. None of the carbon is the part of the main chain. So I'll be using 3, 4. It is dicarbonitrile. Dicarbonitrile. Is this clear? Is this clear? Is this clear, people? I hope this is clear to everyone. Now, talking about those compounds which contains the functional group CHO, aldehyde. Aldehyde. First, we discussed carboxylic. Second was your cyanides. Third is your aldehydes. Right? Third is your aldehydes. Now, in case of aldehydes, CHO. This is your CHO. This is your aldehyde group. Now, this is going to be attached to a chain, basically. This is going to be attached to a chain. Now, guys, try to understand. 3 things again you have to remember. 3 things again you have to remember. As a suffix, either you'll be using al, al, or you'll be using carbaldehyde. As a suffix, either you'll be using al or you'll be using carbaldehyde. When you'll be using al, when the carbon of the aldehyde is the part of main chain. When the carbon of the aldehyde is the part of main chain, you'll be using the term al. When the carbon of the aldehyde is not the part of the main chain, you'll be using the term carbaldehyde. Carbaldehyde. As a prefix, you'll be using the term formyl. As a prefix, you'll be using the term formyl. Now, let's try to use these things in the questions so that you will remember it directly from now onwards. Have a look. Look at this particular one. This is CHO. So, aldehyde group. CHO, aldehyde. CHO, aldehyde. Right? Now, guys, calling this as 1, calling this 2, 3, and 4. So, 4 carbon atoms. So, but everywhere, single bond, ane. Carbon of the aldehyde is the part of main chain. So, it is 1, and I'll be using the suffix al. Now, after E, vowel sound started. So, drop the C. Done. Drop the C. Look at the next one. This is carbon number 1, this is 2, this is 3, this is 4. So, it is 2, 2 dimethyl. 2, 2, it is dimethyl. 2,2 dimethyl. Now tell me one thing. Tell me one thing. How many carbon atoms in the main chain? 4. So it's going to be but. It's going to be but. Everywhere is a single bond, so it's going to be ane. Now, the carbon of the aldehyde is the part of the main chain. Suffix used is al. So drop this E. Look at the next one. 1, 2, and 3. So it is simply going to be prop. Everywhere it's a single bond, so ane, right? At 1 and 3, functional groups, 1, 3, 1, 3. Now both the carbons are the part of the main chain, right? Both the carbons of the aldehydes are the part of main chain. So it's going to be di, and the suffix used is al, right? Perfect? Perfect, people? Perfect. Look at the next one. Look at the next one. 1, 2, 3, 4, 5, 6. So it is first of all going to be cyclohexane. It's first of all going to be cyclohexane, right? Now at 1 and 2, there are 2 functional groups. None of the carbon of the functional group is the part of the main chain. So the suffix used is going to be carbaldehyde, right? So it's 1, 2 dicarbaldehyde. Dicarbaldehyde. Look at this one. Bicyclo compound. Same sized rings. Both are same sized rings. But this particular ring, it contains a functional group. So start from here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So first of all, I'll be writing the term bicyclo. It is bicyclo. Now, 1, 2, 3, 4. 1, 2, 3, 4. In the middle, no carbon atom. So 4, 4, 0. 4, 4, 0. Now tell me how many total carbon atoms? 10. So it's dec. Everywhere it's a single bond. Decane. Decane. Now, at carbon number 2, there's a functional group, right? Which functional group? Aldehyde. The carbon of aldehyde is not the part of the main chain. So at carbon number 2, you'll be writing carbaldehyde. Carbaldehyde, because its carbon is not the part of the main chain. The next one, it's a good one. A very good one. This is a very good one. Okay. It is a Spiro compound first of all, right? In the Spiro ones, we start with that ring which contains less members, which contains less atoms, right? 1, 2, 3, 1, 2, 3, 4. I'll start from here. 1, 2, 3, 4, right? This is 5, this is 6, this is 7, this is 8. Numbering is done. Now here you have got a complex substituent. In the complex substituent, again you have to do the numbering. This is carbon number 1. So at 7, first of all, at 7 you have got a complex substituent. It is going to be what? This one will be used as a prefix now. So it is formyl methyl. Formyl methyl. So it will be written like this. At 7 there is a complex substituent. Then at 1 it is going to be formyl. It is going to be formyl methyl. Formyl methyl. Complex substituent over. Now it is a Spiro compound basically. So write the term Spiro. Write the term Spiro. Now use the brackets. Smaller size ring 1, 2, 3. Larger size ring 1, 2, 3, 4. So it is 3, 4. It is 3, 4. Now there are in total 8 carbon atoms. So it's oct. Everywhere it's a single bond. So it's ane. Now at carbon number 6, it is aldehyde. And carbon of aldehyde is not the part of main chain. So you'll write 6 carbaldehyde. Got it? Got it, guys? Is this one clear? Can you let me know? Is this particular one clear? It has to be clear. Okay. One simpler one. One simpler one. Over here, this is C double bond OH. This is carboxylic. This is CHO. This is aldehyde. Which one to prioritize? At the end of the session, I'll give you the priority list, my dear students. At the end of the session, I'll give you the priority list. But right now, you can remember it like this. Carboxylic acid is given more priority than that of aldehyde. Carboxylic acid is given more priority than that of aldehyde. So start from here. 1, 2, 3, 4, 5, 6. This is to be given priority. So this will be used as suffix. This will be used as prefix. Right? So what should I write? What should I write? At 3, it's going to be formyl. Because I have to use prefix for it. So at 3, it's going to be formyl. 3 formyl. Then it's going to be cyclohexane. 3 formyl. Cyclohexane. 3 formyl. Cyclohexane. At 1, there is a carboxylic acid. The carbon of the carboxylic acid is not the part of the main chain. So it is one carboxylic acid. Got it? Perfect. Perfect, guys. Now, there is one more functional group, that is amide. C double bond O NH2. This is your amide functional group. This functional group can be also attached to a carbon chain. Now, when this is attached to the carbon chain, what all things we have to remember? Again, my dear students, only 3 things I'm giving you. Everywhere 3 things you have to remember. As a suffix, either you will use amide or you will use carbamide. As a suffix, either amide or carbamide. When do we use amide? When the carbon of amide, when the carbon of the amide is the part of main chain, suffix uses amide. When the carbon of the amide is not the part of the main chain, suffix uses carbamide. And as a prefix, you will be using carbamoyl. Carbamoyl. So 3 things. 3 things here. It's the amide basically. It's the amide. C double bond O NH2. Right? As a suffix, either amide or carbamide. Amide or carbamide. Now tell me one thing. If the carbon of amide is the part of the parent chain, is the part of the main chain, then amide. If the carbon of amide is not the part of the main chain, then carbamide. As a suffix, when we use it, we use the name carbamoyl. Carbamoyl. Now try to understand. Try to understand. Few examples. Look at this one. This is 1, this is 2, this is 3, this is 4. So first of all, it is but. Everywhere single bond. So it's ane, right? This is C double bond O NH2. So the carbon of the amide group is the part of the main chain. So I'll be using the prefix as 1 amide. Now after E, vowel started, vowel sound, drop the C. Perfect. So it is butane 1 amide. Yes. Look at the next one. This is 1, this is 2, this is 3. Perfect. So this is prop. This is prop. Everywhere is a single bond. So it's ane. Now at 1 and 3. At 1 and 3, there are 2 amide groups. So it's di. So it's di. It's di. Now, the carbon of amides are the part of main chain. So it is simply diamide. It is simply diamide. It is simply diamide. I believe it's clear. Look at the next one. Calling this 1, 2, 3, 4, 5, 6. So it's cyclohexane. It is cyclohexane, my dear students, right? At carbon number 1, there is a functional group. Which one? It's amide. Now the carbon of amide is not the part of main chain. So I'll be using carbamide. I'll be using carbamide. Right? I'll be using carbamide. Look at this one. Calling this as 1, 2, 3, 4, 5, and 6. So first of all, it's cyclohexane. It is cyclohexane. At 1 and 3. At 1 and 3, there are 2 functional groups. So di. So di. None of the carbon of amide is the part of the main chain. So it is dicarbamide. Carbamide. Because carbon of the amide is not the part of the main chain. Dicarbamide. Next one. Bicyclo. Bicyclo. Both the rings are equal in size, but one ring carries the functional group. So start from here. 1, 2, this is 3, 4, 5, 6, this is 7, 8, 9, and 10. So first of all, you'll be using the term bicyclo. Bicyclo. 1, 2, 3, 4. 1, 2, 3, 4. 0 in between. So 4, 4, 0. 4, 4, 0. How many carbon atoms in total? 10. So it is dec. Everywhere single bond. Ane. At carbon number 2, there's a functional group. The carbon of the functional group is not the part of the main chain. So I'll be using carbamide. Carbamide. I believe it's clear. I believe it's clear. Right? I believe it's clear. Look at these two. Look at these two. You should be able to solve them. You should be able to solve them. You should be able to solve them quickly. What do you think? What do you think about this one? Quickly, guys. What should be the name of it? You should be able to solve this now. is a Spiro one, right? Can be done. Start with the lower size. So 1, 2, 1, 2, 3, 4. 1, 2, 3. Calling this 1, this is 2, this is 3, this is 4, 5, 6, 7, 8. Use the term Spiro first. Use the term Spiro. Then the lower sized ring contains 3 atoms. This is 4. So 3, 4, 3, 4. Now 8 carbon atoms. So it's oct. Everywhere it's a single bond. So ane, octane. At carbon number 6, there is a functional group, and the carbon of the functional group is not the part of main chain. So at 6, it is going to be carbamide. It is going to be carbamide, right? It's going to be carbamide. Look at this particular one. Again, simple. 1, 2, this is 3, this is 4, this is 5, this is 6. If you remember, whenever you see such kind of the scenario in which more than 2 same functional groups starting with carbon are directly attached with the chain, none of the carbon of those functional groups is to be included in the main chain. That's why this has to be the numbering. Already discussed. Already discussed, my dear students. Now try to understand. It is first of all cyclo. Cyclo what? Cyclohexane. It is first of all cyclohexane. Now at 1, 2, 3. 3 functional groups. So it is 1, 2, 3. Right? It is tri. It is tri. None of the carbon of the amide is included in the main chain, right? So I'll write tricarbamide. Tricarbamide, right? Tricarbamide. Sorry, this is not 1, 2, 3, this is 1, 2, 4, right? This is 1, 2, and 4, correct? Not 1, 2, 3. Sorry about that. Guys, I might do some mistakes because I'm writing everything fast. So if you think somewhere instead of 2 I wrote 3, instead of ane I wrote ene or something, do keep on letting me know in the chats, right? Because I'm writing everything fast. So it is understood. Okay? Do keep on telling me that. All right, look at this one. Look at this one. Look at this one. Look at this one. Gopika, I have started from 0 only. Watch the session from the beginning. You'll get it. Look at this one. This is your carboxylic acid. This is your amide. Which one to be prioritized? Carboxylic acid. So it has to be taken as suffix. This has to be taken as prefix. Right? So what is the prefix used for amide? It is carbamoyl. So first start the numbering. 1, 2, 3, 4, 5, 6. So at 4, you have got carbamoyl. At 4, you have got carbamoyl. Then you have got cyclohexane. Then you have got cyclohexane. And at 1, there is carboxylic acid, and the carbon of the carboxylic acid is not the part of main chain. So it is 1 carboxylic acid. 1 carboxylic acid, right? It is not oic acid, guys. It's not oic acid because the carbon of carboxylic acid is not included in the main chain, right? It's not included. Be careful with this. Be careful with this, right? Be careful with this. Now we have got acid halides. One more functional group, acid halide. Acid halide. Again, few things you have to remember. My dear students, acid halide is something like this. C double bond O. This is OX, where X is your halogens. If it is acid chloride, then X is Cl. Acid bromide, then X is Br. Right? Perfect? Okay? If it is acid chloride, then this X has to be Cl. Then this X has to be Cl. Or normally, right now I'm going to talk about acid chlorides only. Okay? I'm going to talk about acid chlorides only. C double bond O. This is OCl. Right? This is OCl. Perfect. This is your acid chloride. Now, my dear students, in acid chlorides, what do we need to do? What do we need to do? As a suffix, 2 things you have to remember. As a suffix, 2 things you have to remember. Either you'll be using oil chloride as a suffix, or you'll be using carbonyl chloride. Oil chloride as a suffix when the carbon of the acid chloride is the part of main chain, and when the carbon of the acid chloride is not the part of the main chain, at that time the suffix uses carbonyl chloride. Oil chloride, carbonyl chloride. When carbon of the functional group is included, when carbon of the functional group is not included. And when we use it as a prefix, there you'll be using alloformyl. 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 Okay, alloformyl. Have a look. Few examples. Few examples. This is C double bond O Cl, right? Guys, just a second. I did a mistake. I think this is not OCl. Sorry. This is C double bond OCl. This is C double bond OCl. Okay. Mistake on my part. This is not OCl. Sorry. This is C double bond O. This is Cl, right? Okay. Okay. Look at this one. This is C double bond OCl. This is 1. This is 2. This is 3. This is 4. Perfect. Now, first of all, the word root has to be but. Everywhere is a single bond. So it's butane, right? The carbon of the functional group is the part of the parent chain, right? So I'll be using oil chloride. So this is 1 and this is oil chloride here. Oil chloride, right? After E, vowel sound is starting. So drop the C. Drop the C. Yeah. Now guys, have a look. This is 1, this is 2, this is 3, this is 4, this is 5. Perfect. Right? So 5 carbon atoms. Now try to understand. Try to understand. See, so it's pent first of all. Everywhere it's single bond. So pentane. Now at 1 and 5, it's going to be di. Carbon of both the functional groups are the part of main chain. So di oil chloride. Di oil chloride, right? Di oil chloride. Perfect. I believe this is again clear. Di oil chloride. Now, few more. Look at this one. Start from here. 1, 2, 3, 4, 5, 6. So what is it going to be? It's first of all going to be cyclohexane. It's first of all going to be cyclohexane. At 1 and 3, functional groups, acid chlorides. None of the carbon of the acid chlorides is a part of main chain. So I'll write 1, 3. It's going to be dicarbonyl chloride. Dicarbonyl chloride, right? Perfect. The next one, Bicyclo, right? Both are equal sized rings. Okay. But this one is substituted. So 1, let me call this as 1, this as 2, this is 3, this is 4, 5, 6, 7, 8, 9, and 10. Now guys, so first of all, you'll be writing Bicyclo because it's a Bicyclo compound. Perfect. Then 1, 2, 3, 4, 1, 2, 3, 4. In the middle, no carbon atom. So 440, right? Then in the main chain, there are 10 carbon atoms. So it's dec. Everywhere is a single bond. So it's ane. Perfect. At 2 and 4, there are 2 acid chlorides and none of the carbon of the acid chloride is included in the main chain. So it's going to be dicarbonyl chloride. Dicarbonyl chloride. Perfect. Dicarbonyl chloride. Moving ahead. Look at this one. 1, 2, 3. 1, 2, 3, 4, 5. Okay. So in case of Spiro compounds, you have to start from that ring, which is lesser in size. So calling this 1, this is 2, this is 3, 4, 5, 6, 7, 8, 9. So first of all, I'll be writing Spiro. In the lower membered ring, 1, 2, 3. In the higher membered ring, 1, 2, 3, 4, 5. 3, 5. In the main chain, 9 carbon atoms. So none. Everywhere it's a single bond. So ane. At carbon number 1, there is acid chloride, right? But the carbon of the acid chloride is not included in the main chain. So it has to be carbonyl chloride. Carbonyl chloride. Perfect. Carbonyl chloride. Look at the next one. Here you have a double bond. Perfect. So start from here. 1, 2, 3, 4, 5, 6. Perfect. So it is cyclohex. At 3, it is ene. At 1, there is a functional group. Which one? It is acid chloride, but carbon of acid chloride is not included in the main chain. So it's going to be directly carbonyl chloride. Okay. Directly carbonyl chloride. Perfect. Okay. Look at these two. You should be able to solve these two as well. It's simple, guys. Calling this 1, this is 2, this is 3, 4, 5, and 6. So first of all, it's cyclohexane. Everywhere it's a single bond, right? Cyclohexane. Now at 1 and 3, it is di. None of the carbon. Oh, sorry. Oh, sorry. Oh, sorry. Oh, sorry. Look at this one. This is C double bond OH. This is carboxylic acid. This is acid chloride. Among carboxylic acid and acid chloride, which one is prioritized? Carboxylic acid will be prioritized, right? Carboxylic acid will be prioritized. So you'll be using it as the suffix, and this has to be used as a prefix. Right? Now start the numbering. 1, 2, 3, 4, 5, and 6. Perfect. Now, as a prefix, what do we use? Haloformyl. So 3 haloformyl. 3 haloformyl, right? Then it's going to be cyclohexane. Cyclohexane. At 1, it's going to be carboxylic acid. Carboxylic acid, because the carbon of the carboxylic acid is not included in the main chain. That's why the suffix uses carboxylic acid here, right? Otherwise, it would have been oic acid. Okay? Otherwise, it would have been oic acid. Look at the next one. Bicyclo, right? Start with the bridgehead, right? Longer ring. 1, 2, 3, 4, 5, 6, 7, 8. So it is bicyclo. Now, in the larger size ring, 1, 2, 3, 4. In the smaller size ring, 1, 2. In the middle, shortest path, there is no carbon. 4, 2, 0. Right? So how many total carbons? 8. So it's oct. Everywhere, it's a single bond. Right? Now, at 7th and 8th position, there are 2 acid chlorides. But none of the acid chloride carbon is included in the main chain. So it's going to be dicarbonyl chloride. Dicarbonyl chloride, right? Dicarbonyl chloride. I believe it's clear. Guys. Now, there is one more functional group, that is sulfonic acid, SO3H. It is at the top of the priority list. It is never used as a prefix. It's always used as a suffix. It's never used as a prefix. It is having the top priority. Okay? So as a suffix, sorry, wait, I told you the reverse. After carboxylic acid, it is going to be sulfo. Okay? So as a suffix, you will be using sulfonic. As a prefix, you will be using sulfo. Carboxylic will be at the top of it. Yes, my bad. So as a suffix, you'll be using sulfonic acid. As a prefix, you'll be using sulfo. Perfect. Now have a look. Here you do not have to see basically, because there is no carbon here. You do not have to see whether carbon is included in the main chain or not. Nothing like that. Okay, nothing like that. Perfect. So as a suffix, sulfonic acid. As a prefix, sulfo. Rest, everything is same. Now you can name anyone. See guys, this is 1, this is 2, this is 3. So it's prop. Everywhere it's a single bond, so it's ane, right? It's 1. As a suffix, it's going to be sulfonic acid. Now look here. This is 1, 2, 3, 4. So first of all, you'll write cyclobutane. At 1 and 2, it's going to be disulfonic acid. Look at this one. 1, 2, 3, 4, 5, 6. So what is going to be? Is it going to be cyclohexane? 1, 3. It is again going to be disulfonic acid only. These are basic things, right? Disulfonic acid. Look at this one. Start from here. 1, 2, 3, 4, 5, 6. 5, 6. Okay. So first of all, it's going to be 4, 4. 4, dimethyl. 4, 4 dimethyl. Then it's going to be cyclohexane. At carbon number 1, there is a sulfonic acid. So 1 sulfonic acid. Look at this one. 1, 2, 3, 4, 5, and 6. At carbon number 2, it's methyl. At carbon number 2, it's methyl. So 2-methyl. Then it's going to be cyclohex. Cyclohex. It's going to be cyclohex. At carbon number 1, there's a double bond. So 1-ene. 1-ene. And 1 sulfonic acid. 1 sulfonic acid. Right? 1 sulfonic acid. Look at the next one. It's bicyclo. Start with the bridgehead carbon. This is the bridgehead carbon. Start from here. Now, larger size ring to be prioritized. So 2, 3, 4, 5, 6, 7, 8. Perfect. 1, 2, 3, 4, 5, 6, 7, 8. So first of all, you write bicyclo. Write bicyclo. In the larger size ring, 1, 2, 3, 4. Right? In the shorter path, only 2 carbon atoms. In the middle, no carbon atom. So 4, 2, 0. Then there are 8 carbon atoms. So it's oct everywhere. Single bond octane. At carbon number 8, you'll write sulfonic acid. You'll write sulfonic acid. Correct? You'll write sulfonic acid. Yes? Perfect. Now the next one. Now the next one. Look at this one. Look at this particular compound. It's a Spiro one, right? So start what? Start from the lesser sized ring. So 1, this is 2, this is 3, this is 4, 5, 6, 7, 8. So first of all, it is going to be Spiro. It's going to be Spiro, right? In the smaller size ring, 1, 2, 3. In the larger size ring, 1, 2, 3, 4, right? In the chain, there are 8 carbon atoms, oct. Everywhere there is a single bond, octane. At 6, there is a sulfonic acid. At 6, there is sulfonic acid. Correct, guys? Now, over here, you have got carboxylic acid and sulfonic acid. Which one to be prioritized? Carboxylic acid, right? Carboxylic acid to be prioritized over sulfonic. So 1, 2, 3, 4, 5, and 6. Perfect. Now, here this will be used as a prefix and this will be used as a suffix because it's having more priority, right? As a prefix, at carbon number 3, there is a sulfonic group, right? So as a prefix, I'll be using sulfo. So 3-sulfo. 3-sulfo, right? 3-sulfo. Then it's cyclohexane. And then at carbon number 1, it is a carboxylic acid. The carbon of COH is not the part of main chain, so it is carboxylic acid. It is 1 carboxylic acid. I hope this is also clear. Sir, 4-sulfo. Okay, this is at 4. Okay, this is 4. Thank you. Done? Done, guys? Is it clear? Is it clear? Is it clear? Now, cyanide group we have discussed. Now there is isocyanide group. N triple bond C. This is your isocyanide group. This is your isocyanide group. For isocyanides, as a suffix, we use the term carbylamine. Carbylamine. As a prefix, we use isocyano. 2 things you have to remember. That's it. Carbylamine, isocyano. Carbylamine, isocyano. Carbylamine as a suffix, when it's given priority. As a prefix, isocyano. For the functional group, N triple bond C. Right? Do remember, the nitrogen of this functional group will be attached with the main chain. If the nitrogen of this functional group is attached to the main chain, it's isocyano. Perfect. Have a look. Have a look, guys. If you look at the first example, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6. So it is 2-methyl. It is 2-methyl cyclohexane. 2-methyl cyclohexane. And at carbon number 1, there is a functional group that is isocyanide, right? And as a suffix, we have to write carbylamine. Carbylamine, right? Similarly, call this 1, call this 2, call this 3. So what is it going to be? It is first of all going to be cyclopropane. It is first of all going to be cyclopropane. And at 1 and 2, There are two functional groups. So I'm writing di, right? I'm writing di. As a suffix, what do we use? We use carbylamine. We use carbylamine. Look at this particular compound. It's a bicyclo compound. It's a bicyclo compound. So both the rings are equal in size, right? So calling this as 1, calling this 2, this is 3, 4, 5, 6, 7, 8, 9, 10. So first of all, it's going to be bicyclo. Bicyclo. 1, 2, 3, 4. 1, 2, 3, 4. It's 440. It's 440. Total 10 carbon atoms, dec. Everywhere is a single bond, so ane. At 3 and 4. At 3 and 4. Two functional groups, so di. And as a suffix, what do we use? Carbylamine. Carbylamine. So these sort of questions you should be able to do. You should be able to do these. Right? Look at this one. Look at this one. Look at this one. It's going to be your homework question. Look at this one. Look at this one. What should be the name of this one? What should be the name of this one? Carboxylic acid and isocyanide. Which one to be prioritized? Carboxylic acid. So start from here. 1, this is 2, this is 3, this is 4, this is 5, this is 6. Perfect. So this one to be used as a suffix, this one to be used as a prefix, in short. So at 2, what do we have? At 2, we have got isocyano. Isocyano. Then it's going to be cyclohexane. Cyclohexane. At carbon number 1, there is a carboxylic acid. So it's 1 carboxylic acid. 1 carboxylic acid. Why carboxylic acid? Because the carbon of carboxylic acid is not the part of the main chain. It's not included in the main chain. Okay, it's not included in the main chain. Perfect? Perfect, guys? There is one more functional group, that is ketone. Ketone, right? Ketone. This is your ketone. Right? This is your ketone. This is your ketone. RC double bond OR. Okay? Now, as a suffix, you'll be using the term one, O-N-E, one. Right? As a prefix, you'll be either using oxo or keto. You'll be either using oxo or keto. Guys, 10 to 15 more minutes. That's all. We are done. We are almost done. We are almost done. Ketone as a suffix will be using on. As a prefix will be either using oxo or keto. Will be either using oxo or keto. See. Now it's simple. 1, 2, 3, 4, 5, 6. What should be its name? Cyclo. X everywhere is a single bond. Hexane. At 1, it's going to be on. Drop the C. Perfect. 1, 2, 3, 4, 5, 6. So cyclo. Hexane. 1, 4 dione. 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 This question, keep it as such till I give you the priority list. Till I give you the priority list. Once you get the priority list, then only you can understand. Then only you can understand whether we have to take this one as suffix or this one as suffix. I'm keeping this question as such because I did not show you the priority list yet. Right? I did not show you the priority list yet. First, I'll show you the priority list, then we'll do this question. Okay? Then we'll do this question. Okay. What about the name of these compounds? Look at these two. Look at these two. Quickly. This you should be able to do. I'll show you this one. It is a Spiro compound. It's a Spiro compound. Start with the lower side. Let's call this as 1. This is 2. This is 3. This is 4. Right? This is 5. This is 6. This is 7. This is 8. So it's first of all going to be 1 methyl. It's first of all going to be 1 methyl because over here it's a methyl group. 1 methyl. Then it's going to be Spiro. Then it's going to be Spiro, right? 1, 2, 3. 1, 2, 3, 4. So 3, 4. 3, 4. then 8 carbon atoms, so oct, everywhere single bond, right? Now at carbon number 6 and 7, two keto groups, so it's going to be dione. This is going to be the name of the compound. Perfect. Perfect, guys. Right? By the way, are you done with this one? Are you done with this one? What is the name of this one? 1, 2, 3, 4, 5. Pentane 2,4-dione, right? Pentane 2,4-dione. It's simple. Pentane 2,4-dione. Now, if you have got the functional group as alcohol, if the functional group is alcohol, then as a suffix ol, as a prefix hydroxy, as a suffix ol, as a prefix hydroxy, as the suffix ol, all, as a prefix hydroxy. For example, look at these. This is directly going to be cyclohexane 1-ol. Drop the C. This is going to be 1,2. It's going to be cyclohexane 1,2 diol. Right? Yes. The next one. 1, 2, 3, 4, 5, 6. It's going to be 3,5-dimethyl. 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 Then you will be writing cyclohexane. Cyclohexane. At 1, it's all. Drop this E. Drop this E. Now here, it's going to be 1, 2, 3, 4, 5, 6. So it is cyclohexene 1-ol. Drop the C. All these rules we have discussed in detail. Right? Guys, I mean, it should not take you now seconds to name these compounds. It should not take you seconds to name these compounds. It should not take you seconds to name these compounds. Quickly, what about this one? 1, 2, 3, 4. So it's simply going to be but. Everywhere single bond, ane. It's 2, 3. 2, 3 diol. Right? Now, it's a bicyclo one. So call this 1, this is 2, this is 3, 4, 5, 6, 7, 8, 9, 10. So it is simply going to be bicyclo. It is going to be bicyclo. Now 440. Bicyclo 440. Perfect. Then 10 carbon atoms. So dec, everywhere single bond. So ane. Now at 3 and 4, it's going to be diol. Correct? At 3 and 4, it's going to be diol. Look at this one. Look at this one. Even I'm not going to show you this one as well because I have used 2 different functional groups. I'm not giving you the priority list yet. Just wait for that. Once you get the priority list, you'll easily understand which one to take prefix, which one to take suffix. And their names as prefix, suffix, you already know. Right? Yes? Yes, Mohammed, you can consult. You can consult, yes, easily. Now, guys, the last functional group, that is thiol, SH group. Instead of OH, you have got SH group now, thiol. As a prefix marcepto, as a suffix thiol. As a suffix thiol, as a prefix marcepto. Right? As a suffix thiol, as a prefix marcepto. Now, how to name this? How to name the compounds? Look at the compounds. I mean, you can easily do. They are similar like your alcohols only. Okay? All right. What is going to be the name of this particular compound? It's simply going to be cyclohexane. And at 1, it's going to be thiol. Perfect. Now, before naming this particular compound, let me quickly show you the priority list. This is the priority list, guys. Carboxylic acid at the top. After that, sulfonic acid, anhydrides, esters, acid halides, amides, cyanides, isocyanides, aldehydes, ketones, alcohols, thiols, right? So alcohol is given more priority over thiol, right? Alcohol is given more priority over thiol. alcohol is given more priority over thiol. So this is 1, this is 2, this is 3, this is 4, 5, and 6, right? So this will be used as a suffix, this will be used as a prefix. So at 3, it's going to be Mars septo. At 3, it's Mars septo. Then you'll be writing cyclo. Then it's going to be hexane. And at 1, it's going to be all, and drop the C. Right? Clear? Clear, guys? This is important, which you have to remember. This is important, which you have to remember. This is important, which you have to remember. And do remember it from now onwards. Okay? And my dear students, with this, the first part of organic chemistry is done. I am 100% sure